Hello everyone, welcome back to Maths Marathon classes. This time I'll take up one of the most important chapter, high weightage chapter, integration. NCERT exercise 7.2, the method of substitution I'm going to take up in this video. All problems solved from NCERT exercise 7.2, the method of substitution, one of the most important methods of integration. Integration itself is the most important chapter, not only for board exams, even for competitive exams, not only at PU level, even after finishing PU, if you join engineering, M1, M2, M3, M4, 4 semesters of mathematics are going to study at engineering level. And integration plays a vital role, not only in mathematics, not only at engineering level in mathematics, and also important for physics also. At PU level only, in physics also to come across integration, right? So it's important. There are various methods of integration, method of substitution, integration by method of partial fractions, by parts, correct? Various methods are there. Integration by method of substitution is one of the most important methods. Okay, so we shall see what is the method of substitution and why it is required. So integration by method of substitution, some of the important points are given here. This method is applicable whenever the given integral contains both the substitute and its derivative. What you are going to substitute and its derivative, both should be present in the given integral. Then we can adopt this method. Not every problem can be solved by method of substitution. Only those problems where the given integral contains the substitute and its derivative, we go by method of substitution. And after making substitution, the given integral is going to reduce it to the standard form. So in integration, we don't have chain rule, we don't have quotient rule, correct? So integrating any function is quite harder compared to differentiating a given function, correct? In differentiation, we got chain rule, correct? Differentiating any function, any complicated function is given. Suppose the function is differentiable, it is possible to differentiate by the known methods, correct? But integration is quite harder, okay, comparatively, relatively harder. Lot of techniques are required, tools are required, skills are required. Of course, trigonometric knowledge is also required, correct? So all those things matters in integration. So why to substitute and what is the purpose of substitution, and after making substitution it becomes it reduces to the standard form. These things you must know, okay? When to substitute and why to substitute. When to substitute, whenever the given integral contains both the substitute and its derivative, we go by the method of substitution. After making substitution, the given integral reduces to the standard form. Okay, these two things you must know. And the method is given here, make a proper substitution and the given integral reduces to the fundamental integrals, the standard forms. Okay. And sometimes the given integral, if it involves a trigonometry function, correct, mainly if it involves a trigonometry function, the substitute will be hidden in that case. Sometimes you have to simplify a little bit using trigonometric formulas, so that then you can identify what to substitute and what derivative is present or not. The derivative of the substitute is present. Okay, in such a way you may have to make an adjustment. Okay, sometimes whenever a trigonometric function is there in the given integral, the substitute may be hidden. Okay, so that is one thing. By experience, by working out more and more number of problems, you'll get the idea. So lot of problems you need to work out. So I'll take up exercise 7.2 of the NCERT textbook. Okay, problems from that section, and given integral like this. Integral of f of g of x into g dash of x dx. That means a composite function is given to you. F of g of x is it's a composite function. Function of function is called as a composite function. So f of g of x, g dash of x. If the given integral takes this form is given to you, then how to proceed? We'll take t is equal to g of x. Normally terms inside the bracket, terms inside the square root, the terms which is present in the denominator sometimes, or terms inside the bracket, terms which is present in the power, if it involves exponential function, power, such terms are taken as t. Okay, so a composite function is given. Terms inside the bracket is g of x. You put t equal to g of x. Differentiate this. dt by dx will be equal to g dash of x. Cross multiply. dt equal to g dash of x into dx. So this integral becomes f of integral of f of g of x is t and g dash of x into dx becomes dt. So the given integral reduces to the standard form after making the substitution. Okay, integral of f of t is capital F of t, where capital F is the antiderivative of small f. So given an integral which involves a composite function f of g of x into g dash of x, in that case we are going to use this method. Okay, so method of substitution. So the method is given here, and there are different forms. Sometimes for competitive exams we can use these methods. Integral of f dash of x by f of x with respect to x is log of mod f of x plus c. You know, integral of dx by x, log of mod x. Integral of 1 by x is log of mod x. Likewise, integral of f dash of x by f of x with respect to x is going to be log of mod f of x plus c. This is similar to integral of dx by x or integral of dt by t. Integral of dt by t is log of mod t, correct? So likewise, integral of f dash of x by f of x with respect to x is log of mod f of x plus c, provided f of x is not equal to 0. And here integral of f dash by root of f of x. This takes the form integral of dx by root x. It is similar to integral of dt by root t. Integral of dt by root t is a 2 root t, right? So similar to that, integral of f dash of x by root of f of x is 2 root f of x plus c. And we have integral of f dash of x by f square of x, that is minus 1 by f of x plus c, where f of x not equal to 0. Here f of x should be positive in the second case. Okay, I can give the conditions also. Integral of f dash by f square is similar to integral of dx by x square. Integral of dx by x square is minus 1 by x, correct? Integral of 1 by x square with respect to x is minus 1 by x. Likewise here, integral of f dash of x by f square of x is minus 1 by f of x plus c. Quite useful for competitive exam, these kind of integrals. Normally for board exams we don't use this, but still I have given it as a important note here. For example, if I give like this, integral of say integral of cos x by 1 plus sin x, cos x by 1 plus sin x with respect to x. If I give an integral like this, then we know that derivative of 1 plus sin x is cos x, correct? Numerator is cos x dx, correct? We can make a substitution. So I can tell cos x is nothing but derivative of 1 plus sin x. Derivative of 1 is 0. Derivative of sin x is cos x. This takes the first form, right? If you take f of x is equal to 1 plus sin x, if you take f of x is equal to 1 plus sin x, in that case I am going to get f dash of x is equal to, derivative of 1 is 0, derivative of sin x is cos x, right? So f dash of x will be cos x. So given integral takes this form, f dash of x divided by f of x. Orally we can answer these kind of integrals. No need work out any, no need do the steps actually if it is for competitive. So you can write this as log of mod f of x plus c. Log of mod f of x is 1 plus sin x. Log of mod 1 plus sin x plus a constant c. Like this we can write. Hope you understand. Suppose I give another example for this, integral of say sin 2x divided by root of 2 plus sin square x. We know that derivative of 2 is 0. Derivative of sin square x is sin 2x, right? Derivative of sin square x is 2 sin x cos x, which is sin 2x, which is present in the numerator. So this integral takes the form f dash of x by root of f of x, correct? If you differentiate 2, it is 0. Derivative of sin square x is 2 sin x into derivative of sin x cos x. 2 sin x cos x is sin 2x. So this takes the form integral of f dash of x by root of f of x. Integral of f dash of x by root of f of x. That is equal to what? 2 root f of x plus c. 2 root f of x plus c. 2 times root of f of x is 2 plus sin square x. Integral of dx by root x is 2 root x, right? So 2 into root of 2 plus sin square x. Integral of f dash by f is 2 root f of x. It is comparable to integral of dt by root t, which is 2 root t. So 2 root f of x. F of x is 2 plus sin square x. Substitute back. So examples are given for these type of forms. Okay, better to learn this. Move on to the next one. I given some of the important results which is frequently used here. Okay. The third one is most important. Many times we come across. Integral of x by 1 plus x square is half log 1 plus x square. In particular, I can write one more here. Integral of 2x by 1 plus x square. Integral of 2x by 1 plus x square is also frequently used. This is log of 1 plus x square. Log of mod 1 plus x square. Actually, mod is not required because 1 plus x square, we know it is always positive for any real number. Correct? So, this is also important. Integral of 2x by 1 plus x square is log of 1 plus x square plus c. Please learn this. And integral of x by 1 plus x square with respect to x is half log 1 plus x square, because you can multiply and divide by it, or you can make a substitution, put t equal to 1 plus x square, x dx will be dt by 2, so half log 1 plus x square again. Half log 1 plus x square could also be written as log 1 plus x square to the power half, which is log of root 1 plus x square. Correct? Half log 1 plus x square, half log 1 plus x square is same as log of 1 plus x square to the power half. Log of 1 plus x square to the power half, which is equal to log of root 1 plus x square. Correct? Log of root 1 plus x square to the power half means it is square root. And these two, the first two are very important for CET point of view. Okay, for CET exams already questions are asked based on this. So to integrate sine power n minus 1x by cos power n plus 1x, what we can do is I can write cos power n plus 1x in the denominator as cos power n minus 1x into cos per x, so that sine power n minus 1x by cos power n minus 1x becomes tan power n minus 1x, and 1 by cos per x is secant square x. I can use method of substitution. You know, derivative of tan is secant square, right? So I can use the method of substitution and get the answer. So for that I can show the steps here. I is equal to integral of, I'll call the integral as I can write the numerator as it is sine power n minus 1x divided by cos power n plus 1x is cos power n minus 1x into cos square x. Correct? I can add the powers here. N minus 1 plus 2 becomes n plus 1. What is given, right? So sine power n minus 1x by cos power n minus 1x is tan power n minus 1x, and 1 by cos square x is secant square x. Here you can put t equal to tan x, the method of substitution. Put t is equal to tan x. Derivative of tan x is secant square x. dt is equal to secant square x into dx. Correct? This becomes integral of t power n minus 1 secant square x into dx is dt. Integral of t power n minus 1 is t power n divided by n plus c. Substitute back for t. T is tan x. So what you get is tan power nx divided by n plus c. Already in CET exams the questions are asked based on this. And the second one is also similar to the first one. You can write denominator sine power n plus 1x as sine power n minus 1x into sine square x, and cos power n minus 1x by sine power n minus 1x is cot power n minus 1x. 1 by sine square is cosecant square. Correct? You can go by method of substitution. Put t equal to cot x, derivative of cot x minus cosecant square x. So you'll end up with getting minus cot power nx by n plus c. Learn these two for CET, okay? And these two, the last two also quite many times it's a frequently used actually. Integral of x by root of 1 plus x square. Root of 1 plus x square. You can go by method of substitution to prove that. Put t equal to 1 plus x square. Derivative of 1 plus x square is 2x. X into dx will be dt by 2, correct? So you can use method of substitution. It becomes half dt by root t. dt by root t integral is 2 root t. 2 will cancel. Half into 2 root t is root t. Root of 1 plus x square. Method of substitution, okay? The fifth one also, it's similar to the fourth one. You can put t equal to 1 minus x square. I can explain it as a reverse process. You know, differentiation and integration are the reverse process of each other, or the inverse process of each other, right? So if you differentiate root of 1 plus x square, you get x by root of 1 plus x square. That is also there. So if you differentiate root of 1 plus x square, if you differentiate root of 1 plus x square, What I'm getting is derivative of root x we know 1 by 2 root x. 1 by 2 root of 1 plus x square into derivative of 1 plus x square is 2x, right? So we'll get x by root of 1 plus x square. If we differentiate root of 1 plus x square, what I'm getting is x by root of 1 plus x square. So if you integrate this, I'll get this. So integral of x by root of 1 plus x square is root 1 plus x square. And derivative of root 1 minus x square is minus x by root of 1 minus x square, right? If you differentiate, I'll add one slide here. If you take derivative of root 1 minus x square, d by dx of root 1 minus x square. Derivative of root x is what? 1 by 2 root x. 1 by 2 root of 1 minus x square into derivative of 1 minus x square, that is minus 2x. Correct? 2 cancels. What we get is minus x by root of 1 minus x square. Correct? So derivative of root 1 minus x square is minus x by root of 1 minus x square. So integral of x by root of 1 minus x square is minus root 1 minus x square. Correct? And I can write like this. Integral of x by root of 1 minus x square is equal to minus root of 1 minus x square, because integration is the reverse process of differentiation. If you integrate this, I should get that. Integral of x by root of 1 minus x square is minus root of 1 minus x square. Hope I understand. That is what is given in this. Okay. So please learn all these things. And one more note is given. Some of the important frequently used derivatives are given. Derivative of sine square x is sine 2x, frequently used in the method of substitution. Derivative of cos square x is 2 cos x into derivative of cos x minus sin x, which simplifies to minus sin 2x. Derivative of cos square x, d by dx of cos square x. How to differentiate cos square x? Differentiate as you differentiate x square, correct? Derivative of cos square x. Differentiate cos square x as you differentiate x square. Derivative of x square is 2x, correct? Derivative of cos square x. Cos square x means cos x the whole square. What do you mean by cos square x? Cos square x means cos x into cos x. This is cos x the whole square. Derivative of x square is 2x. Derivative of cos x the whole square is 2 cos x into derivative of cos x is minus sin x. So this becomes equal to minus 2 sin x cos x, which is sin 2x. Correct? Using double angle formula. 2 sin x cos x is sin 2x. So minus sin 2x. Derivative of cos square x is minus sin 2x. Derivative of sin square x is sin 2x. 2 sin x cos x sin 2x. That is what is given here. And the third one is also very important. This is from logarithmic differentiation. We learned derivative of x power x. U power v derivative, variable power variable. Derivative of x power x is x power x into 1 plus log x, right? So if you integrate x power x into 1 plus log x, I'm going to get x power x. Because integration is the reverse process of differentiation. And derivative of x log x, you apply the product rule, you get 1 plus log x. Derivative of x into e power x, first into derivative of second, plus second into derivative of first. X into derivative of e power x plus e power x into derivative of x1, correct? Can take e power x common, you'll get like this. Learn all these things frequently is working out the problems. Okay. So with this, I'll start with the problems of NCERT book. Before that, I got some proofs here. Prove that integral of tan x is log of mod secant x plus c. Okay. Take the integral as I. You should prove this as a formula. The formula is actually, take it as a formula, but can be proved also. Okay, can be asked for 2 marks in the exams. I is equal to integral of tan x. Take the integral as I. Tan we know sine by cos, right? Tan is sine by cos. So I'll write this as sine by cos. Tan x is sine x by cos x. Whenever there is sin x into dx, we can take t equal to cos x. That is also there. The important technique to be learned. If sin x into dx is present, you can take t equal to in terms of cos. If cos x into dx is present in the given integral, we can put t equal to sin x. Okay. Now you can see sin x into dx. So I'll put t equal to cos x. The method of substitution. Put t is equal to cos x. Put t is equal to cos x. Differentiate this. dt by dx. dt by dx. Derivative of cos x is minus sin x. Derivative of cos x is minus sin x. From this, minus dt is equal to sin x into dx. Minus dt is equal to sin x into dx. Sin x into dx is minus dt. So this becomes integral of minus dt divided by t. Minus you keep outside. dt by t means integral of 1 by t with respect to t. Integral of 1 by t with respect to t is log of mod t. So minus log of mod t. Substitute back for t finally. This is minus log of mod. What is the t you substitute back? T is cos x. And we know the property of log. Minus log a is log 1 by a. Minus log a is equal to log 1 by a. Using the property of logarithms. Minus log a equal to log 1 by a. Using this for a positive, of course. So minus log of mod cos x could be written as log of 1 by cos x. Log of mod 1 by cos x plus a constant c. And 1 by cos x is secant x. So log of mod secant x plus a constant c. For every indefinite integral, we add a constant c. Hope you understand. The proof can be asked for 2 marks. Okay. Tan you write sin by cos. Remember the technique, whenever sin x into dx is given in the integral, we can put t in terms of cos. So I'll put t equal to cos x and differentiate derivative of cos x minus sin x. Minus to take it to that side. Minus dt equal to sin x into dx. So sin x into dx is minus dt. Cos x is t. Integral of dt by t is log of mod t. So t you substitute back. T is cos x minus log of mod cos x plus c, and minus log is log 1 by a using this. Okay. So 1 by cos x is secant x. Hence proved. Integral of tan x is log of mod secant x plus c. Learn this property of log, quite important. Minus log is log 1 by a. Because log 1 by a is log 1 minus log a. Log 1 is 0, right? Log 1 minus log a. Log 1 by a, log 1 by a is log 1 minus log a. Correct? Log 1 is 0. So what you get is 0 minus log a. 0 minus log is minus log a. Correct? So minus log is log 1 by a is used here. Minus log of mod cos x is log mod 1 by cos x. 1 by cos x is secant x. Hope you understand. Move on to the next one. Integral. Prove that integral of cot x is log of mod sin x plus c. Take the integral as I. Then write cot as cos by sin. I is equal to integral of cot x. Take I is equal to integral of cot x. Cot you can write cos x divided by sin x. Cot x you can write cos x divided by sin x. Now put t is equal to sin x. Whenever cos x into dx is there, I'll put t equal to sin x. Put t equal to sin x. Differentiate this. dt by dx is equal to cos x. dt by dx is equal to cos x. So from this dt is equal to cos x into dx. Cos x into dx. Cos x into dx is dt. So this becomes integral of dt by t. Cos x into dx is dt. Sin x is t. dt means 1 dt. Integral of 1 by t is log of mod t. This becomes log of mod t plus a constant c. So I get log of mod t is what? Substitute back. T is sin x. Log of mod sin x plus a constant c. Cos x into dx means you put t equal to sin x. So important technique. Okay. So hence I proved integral of cot x is log of mod sin x plus c. Move on to the next one. Prove that integral of secant x equal to log of mod secant x plus tan x plus c. Take the integral as I. I is equal to integral of secant x. I is equal to integral of secant x. To prove this, what we do is you multiply and divide by secant x plus tan x. That's an important step here. Okay, that you have to remember how to start the problem sometimes. So in this case, I multiply and divide by secant x plus tan x. Multiply and divide by secant x plus tan x. Multiply and divide by secant x plus tan x. To integrate this, I'll use the method of substitution. I'll put t as denominator. If you differentiate the denominator, I get the numerator. Correct? Of course, numerator can be derived from the denominator. So I'll put t equal to denominator. Put t equal to secant x plus tan x. Put t is equal to secant x plus tan x. Differentiate this. dt by dx. dt by dx is equal to derivative of secant x is secant x tan x. Derivative of tan x is secant square x. Correct? Differentiate secant x. Derivative of secant x is secant x tan x. Derivative of tan x is secant square x. From this I can take secant x common. Secant x common. So what we get is tan x plus secant x. Here we have dt by dx. So this is cross multiply. From this dt is equal to what? Secant x into tan x plus secant x dx. Correct? So this numerator is nothing but dt according to this. Secant x into tan x plus secant x into dx. That is numerator. Numerator is dt. Denominator is t. Integral of dt by t. dt means 1 dt. Integral of 1 by t with respect to t is log of mod t. Correct? Log of mod t plus c. Log of mod t plus c. T you substitute back. T is secant x plus tan x. T is secant x plus tan x. Substitute back. And one more thing you must know, for competitive exams it's quite useful. There is another simplified form for this. I mean the log of mod secant x plus tan x. By using trigonometric formulas I can simplify it further and write it as log of mod tan pi by 4 plus x by 2. And secant x plus tan x is 1 by secant x minus tan x. That is also there. So I can give it as a note here. Okay. Secant x plus tan x. Secant x plus tan x. Of course, you can simplify it. Secant is 1 by cos, tan is sin by cos. So I'll get 1 plus sin x by cos x. Correct? 1 plus sin x divided by cos x. I can write cos x as cos square x by 2 minus sin square x by 2. Correct? Half angle formula. 1 you can write cos square x by 2 plus sin square x by 2. Sin x again I can use half angle formula. 2 sin x by 2 cos x by 2. Go on simplified. This kind of simplification already been done in inverse trigonometry function chapter. It will simplify to tan of pi by 4 plus x by 2. Tan of pi by 4 plus x by 2. And secant x plus tan x is also equal to 1 by secant x minus tan x. Secant x plus tan x and secant x minus tan x are reciprocals. Secant x plus tan x and secant x minus tan x are reciprocals. So I can have another alternate formula for this. Integral of secant x could also be written as log of mod tan pi by 4 plus x by 2. Integral of secant x could also be written as log of mod 1 by secant x minus tan x. Okay, so the alternate formulas also it's better to learn for other competitive exams. Board exams they may not use. For competitive exams definitely they'll come across such kind of things. Okay, so please learn all these things properly. Move on to the next one. Prove that integral of cosec x log of mod cosec x minus cot x. Take the integral as I. To prove this, what we shall do is we multiply and divide by cosec x minus cot x. In the previous one, we multiplied and divided by secant x plus tan x. No, to prove that integral of secant x, log of mod secant x plus tan x, what I did, I multiply and divide by secant x plus tan x. Now, to prove this integral of cosec x, I multiply and divide by cosec x minus cot x. Take the integral as I is equal to integral of cosec x dx multiply and divide by cosec x minus cot x multiply and divide by cosec x minus cot x. Then you put t as a denominator. If you differentiate the denominator, I can get the numerator. Of course, I can tell numerator can be derived from the denominator. Okay. Put t as a denominator and differentiate. If you differentiate the denominator, I'll get the numerator. So the given integral reduces to the form dt by t. Integral of dt by t is log of mod t. Over. That's the answer. Put t equal to cosec x minus cot x. Put t equal to cosec x minus cot x. From this, differentiate dt by dx. Derivative of cosec x. Derivative of cosec x is minus cosec x cot x. Derivative of cosec x minus cosec x cot x. Derivative of cot x is minus cosec n square x. Minus of minus, correct? Minus of minus cosec n square x. So that I can take common here. What is common? Minus of minus will be plus here. I'll take cosec x common. Cosec x common. So what remains is cosec x minus cot x. Cosec x minus cot x. This is a dt by dx, correct? So dx will cross multiply. So I'll get cosec x into cosec x minus cot x into dx is dt according to this. So numerator is dt. Integral of dt divided by t. Integral of dt by t is log of mod t. Log of mod t plus c. So this will be equal to log of mod. What is the t? You substitute back. T is cosec x minus cot x. T is cosec x minus cot x plus a constant c. And cosec x minus cot x could also be simplified using trigonometric formulas. Cosec is 1 by sine. Cot is cos by sine. Correct? So simplified form of cosec x minus cot x is 1 by cosec x plus cot x also we can write. One way of writing. Another way is cosec x minus cot x is tan x by 2. Cosec is 1 by sine, cot is cos by sine. So this becomes 1 minus cos x divided by sin x. Okay, 1 minus cos x by sin x. Taking common denominator. Cosec is 1 by sine, cot is cos by sine. So take common denominator, sin x, so get 1 minus cos x by sin x. And you know half angle formulas for 1 minus cos x and sin x. 1 minus cos x is 2 sin square x by 2. Sin x is 2 sin x by 2 cos x by 2. If you simplify, I'll get tan x by 2. So integral of cosec x could also be written as log of mod tan x by 2. And integral of cosec x could also be written as log of mod 1 by cosec x plus cot x, because cosec x minus cot x is cosec x minus cot x is equal to 1 by cosec x plus cot x. 1 by cosec x plus cot x. Like this. Hope you understand. The other forms also I can write for integral of cosec x. Not only log of mod cosec x minus cot x plus c, I can also write as log of mod tan x by 2 plus c. Also I can write log of mod 1 by cosec x plus cot x plus c. And log 1 by is minus log a, that also I can use. Okay. So various forms. Now I shall take the problems from the NCERT textbook. I have taken exercise 7.2 okay, and also the solved examples of NCERT book connected to 7.2 I have taken, okay, the method of substitution. So we shall do in detail all these problems, how we going to write in the board exams, in that way we shall do it. We should not use any shortcut methods here, okay. So systematically I'll write all the steps in detail, how you write in the exams, in that fashion I'll write, okay. So take the integral as I is equal to integral of 2x by 1 plus x square. Already we know the answer for this, log of 1 plus x square plus c, but still I'll do the method. Okay, I'll write all the steps properly. Put t is equal to 1 plus x square. Put t equal to 1 plus x square. Differentiate dt by dx. Derivative of 1 is 0. Derivative of x square is 2x. So dt is equal to 2x into dx. Cross multiply. Dt is equal to 2x into dx. So 2x into dx is dt. So this becomes integral of dt divided by 1 plus x square is t, correct? We taken 1 plus x square as t. dt means 1 dt. Integral of 1 by t is log of mod t. So we get log of mod t plus c. Log of mod t plus c. Finally substitute back for t. T is 1 plus x square. So log of mod 1 plus x square plus c. And mod is not necessary here because 1 plus x square is always positive. So mod 1 plus x square is same as 1 plus x square. So this becomes log of 1 plus x square. Log of bracket I can write 1 plus x square. correct? Because 1 plus x square, we know it's always positive for any real values of x. So it's a very simple question. Put t equal to denominator. If you differentiate the denominator, I get the numerator. So using the method of substitution, we get the answer. Put t equal to 1 plus x square. Differentiate. Derivative of 1, 0. Derivative of x square 2x. dt is equal to 2x into dx. So 2x into dx is a dt. And 1 plus x square is t. Integral of dt by t is log of mod t. Substitute back for t. Get the answer. Okay. Move on to the next one. Integral of log x the whole square divided by x dx. We know derivative of log x is 1 by x. So I'll put t equal to log x here. Okay. Hope you get the idea what to substitute, when to substitute, and why to substitute all these things. Put t equal to log x here. Differentiate. Derivative of log x is 1 by x. dt by dx. dt by dx. Derivative of log x is 1 by x. So this means dt is equal to dx by x. dt equal to dx by x. So the given integral I is equal to, I'll take log x the whole square divided by x. Log x the whole square divided by x dx. Put t is equal to log x, no? So this becomes t square dx by x is dt from this. Because I've taken t equal to log x, differentiate, derivative of log x is 1 by x. So dt equal to dx by x. So dx by x is dt. Integral of t square with respect to t, that is t cube divided by 3 plus c. Correct? Integral of x square we know, x cube by 3. Integral of t square with respect to t is t cube by 3. T you substitute back, t is log x. So what we get is log x the whole cube divided by 3 plus c. Put t is equal to log x. Method of substitution. Integrate by using the standard formula. Integral of t square with respect to t is t cube by 3. Then substitute back for t. T is log x. So log x the whole cube divided by 3 plus c. For every indefinite integral, we add a constant c. That you must know. Correct? So c is a constant of integral called as arbitrary constant. Move on to the next one. Integral of 1 by x plus x log x. Take the integral as I. And in the denominator, you can see that x is common. Take x common there. Okay. I is equal to start with, to begin with, I'll take the integral as I. I is equal to 1 by x plus x log x. Here you can take x common there. 1 by, take x common. So what you get is 1 plus log x. 1 plus log x. Taking x common in the denominator. Now we can put t is equal to 1 plus log x because derivative of 1 is 0. Derivative of log x is 1 by x. If you differentiate 1 plus log x, I'm going to get 1 by x, right? So put t equal to 1 plus log x. Put t is equal to 1 plus log x, the method of substitution. Differentiate this. This implies dt by dx. dt by dx equal to derivative of 1 is 0. Derivative of log x is 1 by x. From this dt is equal to cross multiply. Dx is cross multiply. I get dx by x. dt equal to dx by x. So dx by x is dt. 1 plus log x is t. So this becomes integral of, what is it, dx by x. dx by x is dt from this. dx by x. Correct? dx by x is dt. 1 plus log x is t. dt means 1 dt. Integral of 1 by t is log of mod t. So this becomes log of mod t plus c. T you substitute back finally. Log of mod 1 plus log x. Log of mod 1 plus log x plus a constant c. Move on to the next one. Integral of sin x into sine of cos x. Normally terms inside the bracket, terms inside the square root, terms which is present in the power, such terms are taken as t. That will get the idea by working out more number of problems. Okay. So take the integral as I. Let I be equal to, let I is equal to integral of sin x into sine of cos x. Now, terms inside the bracket is cos x. No, derivative of cos x is of course minus sin x. But you see, sin x into dx is there. No, so I'll take t equal to cos x. Sin x into dx will be minus dt in that case. Terms inside the bracket is cos x. Sin of cos x is a composite function. Correct? Function of function. It takes the form f of g of x. Correct? Sin of cos x is a composite function. So terms inside the bracket is taken as t. So I'll put t equal to cos x here. Put t equal to cos x. Method of substitution. Put t is equal to cos x. Put t is equal to cos x. Differentiate this. dt by dx. dt by dx. Derivative of cos x minus sin x. So from this, what do you get? Minus dt is equal to sin x into dx. Minus dt is equal to cross multiply dx minus you take that side. So sin x into dx is minus dt. Sin x into dx is minus dt. Minus I'll keep outside the integral. Okay? Minus sin of what is cos x? Sin of cos x. This becomes sin of cos x is t. So sin t. Correct? Sin x into dx is minus dt. Minus you keep outside. Integral of sin is minus cos. Minus of minus plus cos t. Plus a constant c. Correct? Integral of sin is minus cos. Minus already there. Minus of minus plus. Finally, substitute back for t. T is cos x. So this becomes cos of cos x. Cos of cos x plus a constant c. So if you differentiate cos of cos x, we'll get minus sin of cos x into derivative of cos x minus sin x. We'll get sin x into sin of cos x. If you have a doubt whether your answer is right or not, so you just differentiate this. You should get the given question back. Suppose you differentiate this. Okay, what do you get? Derivative of cos is minus sin, correct? Minus sin of cos x into derivative of cos x. Derivative of cos x is minus sin x. Derivative of c is 0. Minus into minus will become plus. Sin x into sin of cos x. Correct? So if you differentiate the answer what you got, you should get the given question back. And I am getting it here. Correct? Minus into minus is plus. I am getting sin x into sin of cos x. Derivative of constant is 0. This is differentiating this. D by dx. Hope I understand. Move on to the next one. Integral of sin of ax plus b into cos of ax plus b dx. Here I can make a substitution for t equal to sin of ax plus b, or I can put t equal to cos of ax plus b. Both will do. Any method works because the derivative of sin is cos and derivative of cos is minus sin. Both will do. Any method is possible here. I'll go for substitution. Put t equal to sin of ax plus b. Your answer may look different, but both answers can be proved they are equal. Okay, by of course the constant of integration might change, may vary from by doing by two methods. If you do it by two different methods, the constant of integration may be different, but the variable part is going to be exactly same in both the methods. Okay, by using suitable trigonometric formulas, I can prove both the answers are equal. Okay, equivalent I can tell. Only the constant term can be different because derivative constant is 0. So in one method you may get the constant as minus half. In another method you may get the constant as plus half. Minus half or plus half, in both the cases derivative is 0, right? So that doesn't matter. So integral of a function is going to be unique up to you add a constant. Okay, up to you add a constant, it is going to be unique. So the constant term need not be unique. That is what. So you can do it by either by putting t equal to sin of ax plus b, or by putting t equal to cos of ax plus b. Any method works. I'll go by putting t equal to sin of ax plus b. Put t is equal to sin of ax plus b. Differentiate this. dt by dx. dt by dx. Derivative of sin is cos. Cos of ax plus b into derivative of ax plus b, that is a. Correct? Derivative of sin is cos. Cos of ax plus b into derivative of ax plus b is a. So from this, dt by a is equal to dt divided by a. dt by a is equal to cos of ax plus b into dx. Cos of ax plus b into dx. Correct? So the given integral, I'll call it as I. I is equal to integral of sine of ax plus b into cos of ax plus b. Sine of ax plus b is t. So this is integral of t into cos of ax plus b into dx. That is dt by a. Correct? dt by a. dt by a. dt by a means keep 1 by a outside. 1 by a is kept outside. Integral of t with respect to t. Integral of t with respect to t is t square by 2. Then finally substitute back for t. So this is 1 by a into integral of t is t square divided by 2 plus c. So what I am going to get is 1 by 2a, value of t substitute back, sine square of ax plus b. 1 by 2a sine square of ax plus b plus a constant c. Suppose we go by other method, that is by putting t equal to cos of ax plus b. I will show the steps. Suppose you put t is equal to cos of ax plus b, what are you going to get? T is equal to cos of ax plus b. This is second method. Okay. Second method. In that case, what are you going to get? In this case, dt by dx. Derivative of cos is minus sine of ax plus b into derivative of ax plus b is a. So I'll get dt by a or minus dt by a is equal to sine of ax plus b into dx. Sine of ax plus b into dx is minus 1 by a dt. So this is given integral, no? In that case, I'm going to substitute for sine of ax plus b now. Sine of ax plus b is minus 1 by a dt. In that case, the given integral becomes minus 1 by a, keep outside. Okay, sine of ax plus b into dx minus 1 by a dt. Cos of ax plus b is a t. So t square dt, correct, t dt, sorry, t dt. Integral of t is going to be t square by 2 minus 1 by t dt, and integral of t with respect to t is t square by 2. So minus 1 by a into t square by 2 plus c. So minus 1 by 2a, t is what? Cos of ax plus b. So this becomes, that is minus 1 by 2a into what is the t you substitute by? T is cos of ax plus b, becomes cos square of ax plus b. Correct? Like this we get. See, answer what we got here, 1 by 2a sine square ax plus b plus c. Here we got minus 1 by 2a cos square of ax plus b plus c. Both answer looks to be different, but both are equivalent. Okay? If you differentiate this, you'll get this. If you differentiate this, you'll get this, definitely. Okay? If you want, you can differentiate. And only I can tell you that both the answers are almost same. Only the constant term is different. That also I can show. You know, sine square theta, the power reducing formula. Sine square theta is what? 1 minus cos 2 theta by 2. And cos square theta is 1 plus cos 2 theta by 2. So if you simplify this part here, this will be 1 by 2a into sine square theta is what? 1 minus cos 2 theta. So double angle here. Correct? Divided by 2. 1 minus cos 2 theta by 2. This is the answer in the simplified form by using the power reducing formula. Here what I am going to get? Minus 1 by 2a cos square theta is 1 plus cos 2 theta by 2. 1 plus cos of 2ax plus 2b divided by 2. Correct? Plus c. So look at the answers here. Here minus 1 by 2a in top, minus 1 by 4a. Here 1 by 4a I got. Here the constant part is 1 by 4a. Here minus 1 by 4a. The variable part is minus 1 by 4a into cos of 2ax plus 2b. Here also I am getting the same thing. Minus into plus is minus. In both the cases, the variable part is minus 1 by 4a into cos of 2ax plus 2b. Correct? In both the cases, the variable part is same or the constant term is different. So any method you can do. Both the methods are correct. Don't think that this method is right, that method is wrong, or vice versa. Okay? So both are correct. In this case, I can go for substitution either for t equal to sine of ax plus b or t equal to cos of ax plus b. Any method. Move on to the next one. Integral of 2x into sine of x square plus 1 dx. Here you see it's a composite function. Sine of x square plus 1 is a composite function. Terms inside the bracket we got x square plus 1. We observe that derivative of x square plus 1 is a 2x. So it's suitable that I can take t equal to x square plus 1, the method of substitution. Correct? So take the integral as I is equal to integral of 2x into sine of x square plus 1. Put t equal to x square plus 1. Put t equal to x square plus 1. Differentiate dt by dx. Derivative of x square is 2x. Derivative of 1 is 0. So from this, if you cross multiply, dt is equal to 2x into dx. Dt is equal to 2x into dx. 2x into dx is dt. Correct? So this becomes integral of sine of, what is x square plus 1? T. What is 2x into dx? dt. Integral of sine t is minus cos t. Finally add a constant c. Substitute back for t as well. So minus cos of x square plus 1. Minus cos of x square plus 1 plus a constant c. Put t equal to x square plus 1. Derivative of x square plus 1 is 2x. 2x into dx is dt. So integral of sine t. Integral of sine t is minus cos t. Finally, substitute back for t, x square plus 1. If you have a doubt, you can differentiate this. You will get the given question. Derivative of minus cos is plus sine. Sine of x square plus 1 into 2x. You will get it. Hope you understand. Move on to the next one. Integral of sine of tan inverse x by 1 plus x square. We know that derivative of tan inverse x is 1 by 1 plus x square. We can see tan inverse x as well as 1 by 1 plus x square in the given integral. So I will make a substitution that put t equal to tan inverse x. Put t is equal to tan inverse x and do. Take the integral as I. Let I is equal to integral of sine of tan inverse x divided by 1 plus x square. Sine of tan inverse x divided by 1 plus x square. Here you put t is equal to tan inverse x. Put t is equal to tan inverse of x. Differentiate this. dt by dx. dt by dx. Derivative of tan inverse x. 1 by 1 plus x square. From this, dt is equal to dx by 1 plus x square. Correct? Dx by 1 plus x square is dt. So this becomes what? Integral of sine of tan inverse x is t. Dx by 1 plus x square is dt. Correct? Dx by 1 plus x square, that is dt from this. So integral of sine t with respect to t is minus cos t. Minus cos t plus c. Minus cos of t is substitute back. T is tan inverse x. So integral of sine of tan inverse x by 1 plus x square is minus cos of tan inverse x plus c. Move on to the next one. Question number 8. Integral of tan power 4 root x secant square root x divided by root x with respect to x. Take the integral as I. We know that derivative of tan x is secant square x. So I'll put t is equal to tan root x. Derivative of tan root x by chain rule. Secant square root x into derivative of root x 1 by 2 root x. So take the integral as I first to begin with. Let I is equal to integral of tan to the power 4 root x into secant square root x divided by root x. Put t is equal to tan root x. Put t is equal to tan root x. Differentiate this. dt by dx. dt by dx. Derivative of tan root x is secant square root x into derivative of root x 1 by 2 root x. So find out what is secant square root x dx by root x. From this 2 you cross multiply. I'm going to get 2 dt is equal to 2 dt is equal to secant square root x divided by root x into dx. Correct? Cross multiply this. 2 dt is equal to secant square root x into dx divided by root x. So this part is going to be equal to 2 dt. Correct? Secant square root x dx by root x is 2 dt. 2 is cross multiplied to left hand side. Dx is cross multiplied to right hand side. So 2 I can keep outside. 2 I'll keep outside. Tan root x is t. No? So this becomes t power 4 dt. 2 you keep outside. Integral of t power 4 is t power 5 divided by 5 plus a constant c. So this becomes 2 by 5. T you substitute by t is tan root x. So this becomes tan to the power 5 root x, alright, plus a constant c. Hope you understand this. 2 by 5 tan to the power 5 root x plus c. On to the next one. Integral of x into root of x plus 2 dx. Take the integral as I. Terms inside the square root, no, x plus 2. I'll take it as t so that the given integral reduces to the standard form. Let I is equal to integral of x into root of x plus 2 dx. Put t is equal to x plus 2. Write everything in terms of t here after making substitution. So from this dt by dx, derivative of x is 1, derivative of 2 is 0, cross multiply this, dt is equal to dx, so this becomes integral of, what is x? X is t minus 2, t is x plus 2, so x is t minus 2. Writing everything in terms of t, correct? T is x plus 2. From there, x will be t minus 2. X is t minus 2. Root of, what is x plus 2? T. Dx is dt. Correct? This becomes integral of t root t minus 2 root t multiply, open the bracket, dt is there. Correct? T root t means it is t power 3 by 2, correct, minus 2 into root t is t power half. See, before it was not possible to multiply here. I can't multiply x into root x or x into root 2, I can't multiply that. After making substitution for x plus 2 as t, writing everything in terms of t, now t root t is t power 3 by 2 and root t is t power half, correct? Hope you understand. T root t is nothing but t power 3 by 2. If you don't know, I'll write here. T root t is equal to what? T means t power 1. Root t means t power half. Correct? So I can add the powers. Bases are same. So we can add the powers. 1 plus half. 1 plus half is 1 and a half. That is 3 by 2. T power 3 by 2. If bases are same, we can add the powers. 1 plus half. 1 plus half is 1 and a half. 1 and a half is 3 by 2. So t root t is nothing but t power 3 by 2. At this stage, it is possible to integrate using integral of x power n formula. Integral of x power n is what? X power n plus 1 by n plus 1. So integral of t power 3 by 2 is t power 3 by 2 plus 1 by 3 by 2 plus 1. So t power 3 by 2 plus 1 is 5 by 2. So this becomes t power 5 by 2 by 5 by 2. T power 3 by 2 plus 1, 5 by 2 divided by 5 by 2 minus 2 into integral of t power half is t power half plus 1 by half plus 1. Half plus 1 is 3 by 2, correct? So this becomes t power 3 by 2 divided by 3 by 2 plus c. Or 1 by 5 by 2 will become 2 by 5, correct? This will go up. This will go up, correct? 2 goes up. 2 by 5. T power 5 by 2. T I'll substitute back simultaneously. T is what? X plus 2. 2 by 5 x plus 2 to the power 5 by 2 minus. Here this 2 will go up. 2 into becomes 4. 4 by 3. What is the t? Substitute back. X plus 2 to the power 3 by 2 plus c. Hope I understand this. 1 by 5 by 2 is 2 by 5. 2 by 3 by 2. This 2 goes up. 2 2 is 4. 4 by 3 it becomes. This is method of substitution. Next one. Take the integral as I. Terms inside the square root, we can take it as t here. T equal to 1 plus 2x square. If you differentiate 1 plus 2x square, I get 4x. And x into dx will be dt by 4, correct? So x into dx could be written as dt by 4. Using method of substitution, it is possible to integrate. It can be reduced to the standard forms by using the method of substitution, and then we can integrate. Let I is equal to integral of x into root of 1 plus 2x square. Put t is equal to 1 plus 2x square. Use the method of substitution. T equal to 1 plus 2x square. From this, differentiate dt by dx. Derivative of 1 is 0. Derivative of 2x square is 4x. So from this, dt by 4 is equal to x into dx. dt by 4 is equal to x into dx. So this becomes integral of, what is x into dx? dt by 4. X into dx is dt by 4, means 1 by 4 you keep outside. X into dx is dt by 4, correct? 1 by 4 dt. Root of, what is 1 plus 2x square? T. Root of, what is 1 plus 2x square? T. So this becomes 1 by 4 into integral of root t. Integral of root t is 2 by 3 t root t. Direct I'll write. Okay. Integral of root x. What is integral of root x? Root x means x power half. Correct. Integral of x power half is x power half plus 1 divided by half plus 1. Half plus 1 is 3 by 2. So what I am getting here? X power 3 by 2 divided by 3 by 2 plus c. Correct? That is 2 by 3 x power 3 by 2. I can write integral of root t as 2 by 3 t power 3 by 2. Or 2 by 3 t root t, because t power 3 by 2 is t root t. So 2 ones are 2, 2s are cancelled. So 1 by 6 I'll get. 1 by 6. What is a t? Substitute back. 1 plus 2x square. 1 plus 2x square to the power 3 by 2 plus a constant. Hope you understand. The method of substitution is used. Normally, terms inside the bracket, terms inside the square root, correct? Such terms are taken as t. If it is e power something, that e power, the power is taken as t. Normally, I'm telling most of the time, I can give guarantee. Okay, the exception case might be there sometimes. Depends upon the given integral. Next one, integral of 4x plus 2 into root of x square plus x plus 1. How to integrate this? First, we see that you can take 2 common in this. The first bracket, 2 is common. Let I is equal to integral of 4x plus 2 into square root of x square plus x plus 1. Here you can take 2 common from this. 2 if you take common, this becomes 2x plus 1 into root of x square plus x plus 1. Correct? If you differentiate the terms inside the root, no? Derivative of x square is 2x. Derivative of x1. Derivative of 1, 0. So it's suitable to take t equal to x square plus x plus 1. I'll put t as x square plus x plus 1. The method of substitution. If you differentiate x square plus x plus 1, I'm going to get 2x plus 1. Which is already present in the given integral. Correct? First, I have to simplify 4x plus 2 by taking 2 common. 4x plus 2 is 2 times 2x plus 1. Now I can put t is equal to x square plus x plus 1. Method of substitution. Put t equal to x square plus x plus 1. Differentiate this. dt by dx. dt by dx. Derivative of x square 2x. Derivative of x 1. Derivative of 1 0. From this, dt is equal to 2x plus 1 into dx. 2x plus 1 into dx, that is dt. 2x plus 1 into dx is dt. Correct? 2 into integral of root of what is x square plus x plus 1? T. So root t and 2x plus 1 into dx is dt. Integral of root is 2 by 3 t power 3 by 2, or I can write 2 by 3 t root t. Okay, 2 is already there, constant, keep as it is. Integral of root is 2 by 3 t power 3 by 2 plus a constant c. So 2 into 2 becomes 4. 4 by 3, substitute back for t finally. T is x square plus x plus 1. X square plus x plus 1 to the power 3 by 2 plus a constant. Move on to the next one. Question number 12. Integral of 1 by x minus root x. Take the integral as I. Let I is equal to integral of 1 by x minus root x dx. First we'll simplify here. It's not so direct here. We know that derivative of root x is 1 by 2 root x. 1 by 2 root x is not present exactly there, correct, in the given integral. So what we'll do is we'll simplify here. This is equal to integral of 1 by, I'll write x as root x into root x. Correct? Write x as root x into root x. Take root x common in the denominator. So what do you get? This is equal to integral of 1 by root x common. What do you get is root x minus 1. Root x is common. So now I'll take t equal to root x minus 1. Terms inside the bracket is taken as t. Put t equal to root x minus 1. Put t equal to root x minus 1. Differentiate this. dt by dx. Derivative of root x is 1 by 2 root x. Derivative of 1 is 0. I want to find, I've taken t as root x minus 1, right? I've taken t as root x minus 1. This is taken as t, correct? I want to find what is 1 by root x into dx. This part I want to find. What is dx by root x? So I'll cross multiply this. From this, I can write 2 dt is equal to dx by root x. On cross multiplication, 2 dt is equal to dx by root x. So what is rounded off here? Dx by root x, that is 2 dt, correct? This is equal to 2 we can keep outside. Integral of dt divided by root x minus 1 is t, correct? Dx by root x is 2 dt according to this. That 2 is kept outside. So dt divided by root x minus 1 is t. Integral of dt by t is log of mod t. So this is 2 times log of mod t. So this is equal to 2 times log of mod. What is the t you substitute? T is root x minus 1. Hope you understand this. First to simplify, write x as root x into root x. Then take root x common. So 1 by root x into root x minus 1. Put t equal to root x minus 1. The method of substitution and get the answer. Move on to the next one. Integral of 1 by x into log x power m dx. Let I is equal to integral of 1 by x into log x to the power n. We know that derivative of log x is 1 by x. So put t equal to log x. Put t equal to log x. The method of substitution. Derivative of log x is 1 by x. In the given integral, you see that log x is present, 1 by x is present. Both are present. Given integral contains both the substitute and its derivative. So put t equal to log x. Differentiate. dt by dx is 1 by x. dt by dx is equal to 1 by x. So from this, what we get is dt is equal to dx by x. Correct? So dx by x is dt. So this becomes integral of dx by x is dt, log x is t. So this becomes, the denominator is t power m, 1 by t power m. Correct? Dt means 1 dt. Of course, 1 is there here. 1 dt. So this t power m, take it up, becomes t power minus m. Integral of t power minus m is t power minus m plus 1 by minus m plus 1 plus a constant. Finally substitute back for t. T power minus m plus 1 divided by minus m plus 1 plus a constant c. What is t? You substitute back. T is log x. Log x to the power minus m plus 1 divided by minus m plus 1 plus a constant c. Minus m plus 1 same as 1 minus m, that also you can write. Okay, both one and the same. Hope you understand. By practicing many questions you'll get the idea, and first of all you must be knowing all the formulas. Without knowing the formulas it's not possible. You must know the differentiation formulas as well as integration formula. Both you must be knowing, then only it's possible. If you don't know derivative formula, how do you proceed then? First learn the formulas, okay, please. Those who are watching this video, those who want to learn, those who want to improvise in integration, you must learn the formulas. Differentiation formula first you learn, it becomes easy. If you learn the differentiation formula, integration is also the reverse process of the differentiation. So it's quite natural that you learn the integration formulas also there itself. It doesn't take much time. If you learn differentiation formulas, integration formula also becomes easy. Don't have to spend much time for integration formulas. It's almost the reverse, it's a reverse process and becomes easy. Correct? T equal to log x here, derivative of log x 1 by x. So dx by x is dt. Dx by x is dt, log x is t, see t power m, take it up, t power minus m. Integral of t power minus m is t power minus m plus 1 by minus m plus 1. What is t? Substitute back log x. Next one, take the integral as I here. 13th one was the 14th one. Take I is equal to the given integral. Let I is equal to integral of x divided by 9 minus 4x square. Put t is equal to 9 minus 4x square. The denominator equal to t you take. Then differentiate. Put t equal to 9 minus 4x square. Put t is equal to 9 minus 4x square. Differentiate this. Because if you differentiate the denominator, I can get the numerator. Not exactly. The variable part will be same. The constant part may be missing. Okay. I mean, the constant part, whatever you get from the derivative of this, may not be present in the numerator, but the variable part will be present. That's enough for us. So that means numerator can be derived from the denominator. So I am putting t as 9 minus 4x square. So differentiate this. Derivative of 9 is 0. Derivative of 4x square is 8x. So from this, I can find out what is x into dx. X into dx will be dt by minus 8. dt divided by minus 8. dt by minus 8 is equal to x into dx. Correct? Minus 8 to bring down. So x into dx is dt by minus 8. dt by minus 8 means minus 1 by 8 to keep outside. Minus 1 by 8 will keep outside, okay? That's better. No need to write inside the integral. I'll keep minus 1 by 8 outside. X into dx is dt by minus 8. That is minus 1 by 8 will keep outside. dt divided by 9 minus 4x square is t. dt means 1 dt. So integral of dt by t is log of mod t. Correct? Then finally substitute back for t. So this is minus 1 by 8 log of mod t plus c. So what we get is minus 1 by 8 log of mod, what is the t you substitute back? T is 9 minus 4x square. 9 minus 4x square plus c. Put t equal to 9 minus 4x square. Derivative of 9 minus 4x square is derivative of 9 0. Derivative of 4x square 8x. 0 minus 8x. X into dx is dt by minus 8. So minus 1 by 8 kept outside. Integral of dt by t log of mod t Finally, substitute back for t. This answer. Hope you understand. Move on to the next one. Question number 15. Take the integral as I. You see that tan inverse x is present, and derivative of tan inverse x is 1 by 1 plus x square. You can see 1 plus x square in the denominator. So put t equal to tan inverse of x. Use method of substitution. Let I is equal to integral of e power tan inverse x divided by 1 plus x square. Put t is equal to tan inverse of x. Put t is equal to tan inverse of x. Differentiate this. dt by dx. dt by dx. Derivative of tan inverse x. 1 by 1 plus x square. Correct? From this, dt is equal to dx by 1 plus x square. dx by 1 plus x square. So dx by 1 plus x square is dt. Tan inverse x is t. So this becomes integral of e power. Tan inverse x is t. dx by 1 plus x square is dt. Integral of e power t is e power t plus c. Finally, substitute back for t. T is tan inverse x. E power tan inverse x plus a constant c. Put t equal to tan inverse x. Derivative of tan inverse x 1 by 1 plus x square. T is tan inverse x. dx by 1 plus x square is dt. From this, substitute this. Integral of e power t with respect to is e power t. So answer is e power tan inverse x plus a. Quite simple question. Move on to the next one. You see that the given integral contains sin inverse of x, and derivative of sin inverse x is also present, 1 by root of 1 minus x square. So I'll put t equal to sin inverse of x. Take the integral as I. Let I is equal to integral of sin inverse of x divided by root of 1 minus x square. Put t is equal to sin inverse x. Method of substitution. Put t is equal to sin inverse of x. Differentiate this. dt by dx. Derivative of sin inverse of x. 1 by root of 1 minus x square. Derivative of sin inverse of x. From this, you cross multiply. dt is equal to dx by root of 1 minus x square. So dx by root of 1 minus x square is dt from this. Correct? So this integral becomes sin inverse of x is taken as a t. Correct? Sin inverse of x is t, and dx by root of 1 minus x square. From this, it is dt. Integral of t with respect to t is t square by 2. t square by 2 plus c. Finally, substitute back for t. T is sin inverse of x. So they get sin inverse of x the whole square divided by 2 plus a constant c. Substitute back for t. T is sin inverse of x. Get the answer. On to the next one, question number 17. Integral of cos root x divided by root x dx. Take the integral as I. So what is highlighted in this question is root x. So put t equal to root x. Derivative of root x 1 by 2 root x. Correct? So I'll go by method of substitution by taking t equal to root x. Take the integral as I. Let I is equal to integral of cos root x divided by root x dx. Put t equal to root x. Put t is equal to root x. Differentiate this. dt by dx. dt by dx. Derivative of root x is 1 by 2 root x. Correct? dx by root x is 2 dt. Cross multiply. From this, 2 dt is equal to cross multiply. 2 dt is equal to dx by root x. Cross multiply. 2 dt is equal to dx by root x. So dx by root x is 2 dt. Correct? Integral of cos of what is root x? T. Cos t. What is dx by root x? Dx by root x is 2 dt from this. 2 I'll keep outside. Integral of cos t with respect to t is sin t. So 2 into sine t plus c. T substitute back finally. We get the answer as 2 into sine root x plus c. On to the next one. Integral of root of sine 2x into cos 2x dx. Take the integral as I. What is present inside the root? Sine 2x. We'll take t equal to sine 2x. Derivative of sine 2x is cos 2x into derivative of 2x2. Let I is equal to integral of root of sine 2x into cos 2x into dx. Put t equal to sine 2x. Put t is equal to sine 2x. Terms inside the square root is taken as t here. Derivative of sine 2x is cos 2x into derivative of 2x2. Correct? By chain rule. From this dt by dx. dt by dx is equal to derivative of sine 2x. Cos 2x into derivative of 2x, that is 2. So cos 2x into dx is dt by 2 from this. dt divided by 2 is equal to cos 2x into dx. Cos 2x into dx, dt by 2. dt by 2 means keep 1 by 2 outside. Cos 2x into dx, this is dt by 2. dt by 2, that 1 by 2 is kept outside. dt I'll write here. Root of, what is sine 2x we taken? Sine 2x is taken as t. So this becomes half into integral of root t is 2 by 3 t power 3 by 2. Correct? So this is 2 by 3 t power 3 by 2 plus a constant. Here 2 cancels. So what I'm getting is 1 by 3 into t you substitute back. T is sine 2x. So 1 by 3 into sine 2x to the power 3 by 2 plus a constant c. Hope I understand. 2 got cancelled. 1 by 3 into sine 2x power 3 by 2 plus. Next one, question number 19. Integral of 1 by cos square x into 1 minus tan x the whole square. 1 by cos square x is secant square x. Correct? You know derivative of tan is secant square. So first we'll rewrite this as 1 by cos square x is secant square x. So let the integral be equal to I. I is equal to, I'll write 1 by cos square x as secant square x. Take it to numerator. Directly I'll write secant square x divided by 1 minus tan x the whole square. Put t equal to 1 minus tan x. Because you know derivative of tan is secant square, no? So secant square can be derived from tan. Because derivative of tan x is secant square x. So I'll put t equal to 1 minus tan x. Terms inside the bracket of the denominator. Put t is equal to 1 minus tan x. Put t is equal to 1 minus tan x. Differentiate this. dt by dx. dt by dx. Derivative of 1 is 0 minus derivative of tan x is secant square x. So from this what we get is minus dt is equal to secant square x into dx. Correct? Minus you keep that side. Minus dt is equal to secant square x into dx. Secant square x into dx is minus dt. So what I'm getting is minus dt divided by 1 minus tan x is t, becomes t square. Minus you keep outside. Integral of 1 by t square. dt means 1 dt. Integral of 1 by t square is minus 1 by t. Minus of minus becomes plus 1 by t. Correct? Is equal to 1 by t. T is 1 minus tan x. Substitute back finally. First you write 1 by cos square x as secant square x. Then use method of substitution. Put t equal to 1 minus tan x. Hope you understand this. Move on to the next one. Integral of cos x by root of 1 plus sin x. Here terms inside the root you should take it as t because derivative of 1 plus sin x is cos x. And also moreover I told whenever there is cos x into dx we'll take t in terms of sine. correct? That is also there. So put t equal to 1 plus sin x and do it. Put t equal to 1 plus sin x. Differentiate this. dt by dx is equal to derivative of 1, 0. Derivative of sin x is cos x. So from this, dt is equal to cos x into dx. This becomes I is equal to integral of what is cos x into dx dt. I take I as integral of cos x by root of 1 plus sin x. Cos x into dx is dt. Cos x into dx is dt divided by root of 1 plus sin x is t. Correct? dt means 1 dt. Integral of 1 by root t. Integral of 1 by root is 2 root t. Correct? 2 root t plus c. 2 root t plus c. 2 root of what is t, substitute back. T is 1 plus sin x. Using method of substitution, we get the answer. Put t equal to 1 plus sin x. Derivative of 1 plus sin x is cos x. dt equal to cos x into dx. So cos x into dx is dt. dt by root. Integral of 1 by root is 2 root t. Substitute back for t. t is 1 plus sin x. Move on to the next one. Integral of cot x into log of sin x. So how to start the problem, whether to take t equal to log of sin x or t equal to cot x. Sometimes you may get confused. Here you see, if you differentiate log of sin x, what are you going to get? Derivative of log x is 1 by x. Derivative of log of sin x is 1 by sin x into derivative of sin x is cos x. So if you differentiate log of sin x, I am getting cot x. But if you differentiate cot x, I won't get log of sin x. If you differentiate cot x, I'll get minus cosecant square x. Of course, minus cosecant square x is not found in the given integral, correct? So I'll put t equal to log of sin x. Method of substitution. If you put t equal to log of sin x, derivative of log of sin x is cot x. So I'll put t equal to log of sin x here. Put t equal to log of sin x. Put t equal to log of sin x. Differentiate dt by dx. Derivative of log of sin x is 1 by sin x into derivative of sin x is cos x. So this is cot x. dt by dx is equal to cot x. So from this you cross multiply. dt is equal to cot x into dx. Cot x into dx. Cot x into dx is dt. So I is equal to integral of cot x into log of sin x. Log of sin x is t, correct? Log of sin x is t. So cot x into dx is dt. So given integral becomes integral of t dt. Integral of t with respect to t is t square by 2 plus c. Log of sin x is t. Cot x into dx is dt according to this, correct? So it reduces to integral of t dt. Integral of t with respect to t is t square by 2. T you substitute back finally. 1 by 2 into t square. T is log of sin x. T is log of sin x, the whole square plus c. T square by 2 is half into t square. Half into t you substitute back. T is log of sin x. Move on to the next one. Integral of root of tan x divided by sin x into cos x. You know that derivative of tan x is secant square x. What is highlighted here is root of tan x. Root is highlighted. Terms inside the root is tan x. And derivative of tan x is secant square x. But secant square x is not present in the given integral, correct? But I can rewrite this integral so that I can get secant square x. I can make some suitable adjustments so that I can get the form of root of tan x into secant square x, because the derivative of tan x is secant square x. So what we'll do is here in the denominator we'll multiply and divide by cos x. Multiply and divide by cos x. Or else tan is sine by cos. No, so sine is tan into cos. That it also will do. Tan x is sin x by cos x. So sin x is tan x into cos x. That method also works. Let I is equal to integral of root of tan x divided by sin x into cos x is given, correct? What we can do is we can multiply and divide by cos x in the denominator. So that sin by cos is tan. Cos already there, another cos comes. No, cos into cos becomes cos square. 1 by cos square is secant square, correct? So multiply and divide by cos x in the denominator. Root of tan x divided by sin x divided by cos x. Already one cos x is there, another cos x will get. Multiply and divide by cos x in the denominator. Sin by cos is tan. Cos into cos becomes cos square. 1 by cos square x is secant square x. Root of tan x into secant square x divided by tan x. Correct? Cos x into cos x, cos square x. 1 by cos square x is secant square x. Sin by cos is tan. And I can write tan x as root of tan x into root of tan x. So that one root of tan x will cancel. Correct? So I'll write here, therefore I is equal to integral of root of tan x into secant square x divided by this tan x. I'll write root of tan x into root of tan x. Root of tan x is going to cancel. So what remains is integral of secant square x divided by root of tan x. Here you put t is equal to tan x. Put t is equal to tan x. Differentiate dt by dx. Derivative of tan x is secant square x. So from this dt is equal to secant square x into dx. Numerator is dt. Secant square x into dx is dt. Denominator is root of t. Root of tan x. Tan x is t, no? So root t. Integral of dt by root is 2 root t. Correct? This becomes 2 root t plus c. This becomes 2 into root of, what is the t substitute by? T is tan x. 2 into root of tan x plus c. Hope you understand this. Important step, multiply and divide by cos x in the denominator. Sin by cos is tan. Cos into cos, cos square taken up. 1 by cos square x secant square x. Then write tan x as root of tan x into root of tan x. This tan x is written as root of tan x into root of tan x. 1 root of tan x will cancel. So secant square x by root of tan x. Now put t is equal to tan x. Put t is equal to tan x. Derivative of tan x is secant square x. dt equal to secant square x into dx. Secant square x into dx is dt. dt by root. Integral of dt by root is 2 root t. Substitute back for t. So 2 root of tan x plus c. Sometimes in the competitive exams, they can ask in terms of root of cot x also. Okay, if they give root of cot x by sin x into cos x, then you multiply and divide by sin x. Okay, because sin into sin will be sin square. 1 by sin square is cosecant square. Instead of tan, if they give cot x. And sometimes I've seen in papers in different competitive exams, they give in the question like integral of root of tan x divided by sin 2x. Instead of sin x into cos x, they given sin 2x. And we know the formula, sin 2x is 2 sin x cos x. It is almost same as this. Correct? So questions can be twisted. Next one. Integral of sin x by 1 plus cos x. Quite simple question. Can you try this? Put t equal to 1 plus cos x. Whenever sin x into dx is there, put t in terms of cos. Put t equal to 1 plus cos x into. Can you try this? Put t is equal to 1 plus cos x. Take the integral as I is equal to sin x divided by 1 plus cos x. Put t is equal to 1 plus cos x. Differentiate this. dt by dx. Derivative of 1 is 0. Derivative of cos x is minus sin x. Derivative of 1 is 0. Derivative of cos x is minus sin x. So sin x into dx becomes minus dt from this. This implies minus dt is equal to sin x into dx. Correct? Minus dt is equal to sin x into dx. So this becomes integral of minus dt divided by 1 plus cos x is t. Minus you keep outside. Integral of dt by t is log of mod t. Log of mod t plus c. Finally substitute back for t. So we get minus log of mod 1 plus cos x plus a constant c. Move on to the next one, question number 24. Integral of sin x by 1 plus cos x the whole square with respect to x. Take the integral as I. Because there is sin x into dx, you put t equal to 1 plus cos x. Let I is equal to sin x by 1 plus cos x the whole square. Put t is equal to 1 plus cos x. Put t is equal to 1 plus cos x. Differentiate dt by dx. Derivative of 1 is 0. Derivative of cos x is minus sin x. So from this I get minus dt is equal to sin x into dx. Minus dt is equal to sin x into dx. Sin x into dx is minus dt. Minus you keep outside. Integral of minus dt divided by 1 plus cos x is t. So becomes t square. Minus you keep outside. Integral of 1 by t square is minus 1 by t. Minus of minus becomes plus 1 by t. So 1 by, what is the t you substitute by? T is 1 plus cos x. Hope you understand. Simple question. Because there is sin x into dx, we take t in terms of cos. Take t equal to 1 plus cos x. Derivative of 1 0. Derivative of cos x minus sin x. Or minus dt equal to sin x into dx. So sin x into dx is minus dt. Minus dt by t square. Minus kept outside. Dt means 1 dt. Integral of 1 by t square is minus 1 by t. Minus of minus plus. 1 by 1 plus cos x. Move on to the next one. Take the integral as I here. We can rewrite this integral as I is equal to integral of x plus 1 into x plus log x the whole square divided by x. This is given to us. I can write this as x plus 1 by x into x plus log x the whole square. See, a into b by c. A into b by c same as a by c into b. Correct? A by c into b. So I can write this as integral of x plus 1 by x plus 1 by x into x plus log x the whole square. Correct? A into b by c same as a by c into b, or you can write b by c into a, both are same. I can also write this as a into b by c, both one and the same. Correct? So I can write this as x plus 1 by x into x plus log x whole square. Now I'll put t equal to x plus log x. Also I can separate the terms for this. x plus 1 by x could be written as x by x plus 1 by x. Because numerator is sum of two terms, I can separate the terms. We know a plus b by c. A plus b divided by c is what? A by c plus b by c. A by c plus b by c. So separate the terms in this case. So what we get? Integral of x by x is 1 plus 1 by x into x plus log x the whole square. Now you put t is equal to x plus log x. Put t is equal to x plus log x, method of substitution. Put t equal to x plus log x. If you differentiate x plus log x, I get 1 plus 1 by x. So 1 plus 1 by x can be derived from x plus log x. So I put t equal to x plus log x. Put t is equal to x plus log x. Terms inside the bracket is taken as t. So differentiate this. dt by dx. Derivative of x is 1. Derivative of log x is 1 by x. So from this dt is equal to 1 plus 1 by x into dx. So 1 plus 1 by x into dx is dt. Correct? So this becomes integral of what is x plus log x? T. So this becomes integral of t square dt. Correct? X plus log x is t. T square. 1 plus 1 by x into dx is dt. Integral of t square with respect to t is t cube divided by 3. T cube divided by 3 plus c. Finally substitute back for t. T is x plus log x. So x plus log x the whole cube divided by 3 plus a constant c. Hope I understand this. First to simplify, x plus 1 by x into x plus log x whole square. Separate like this terms. Group the terms like this. Then you can separate the terms in this bracket. A plus b by c is a by c plus b by c. And use method of substitution. Put t equal to x plus log x. Derivative of x 1. Derivative of log x 1 by x. So 1 plus 1 by x into dx is dt. This becomes t square. Integral of t square with respect to t. T cube by 3. Finally substitute back for t. Move on to the next one. Question number 26. Integral of x cube into sine of tan inverse x power 4 divided by 1 plus x power 8. You take the integral as I. Let I is equal to. Let I is equal to integral of x cube into sine of tan inverse x power 4 divided by 1 plus x power 8. We'll take t is equal to tan inverse x power 4 because derivative of tan inverse x is 1 by 1 plus x square. Derivative of tan inverse x power 4 is 1 by 1 plus x power 4 square into derivative of x power 4 which is 4x cube. Put t equal to tan inverse x power 4. Put t is equal to tan inverse of x power 4. Differentiate this. dt by dx. dt by dx. Derivative of tan inverse x. 1 by 1 plus x square. 1 by 1 plus x power 4 square into derivative of x power 4 which is 4x cube by using chain rule. Differentiate using chain rule. Derivative of tan inverse x is 1 by 1 plus x square. Derivative of tan inverse x power 4 is 1 by 1 plus x power 4 square into further differentiate x power 4 which is 4x cube. So I taken tan inverse x power 4 as d. I need to find what is x cube dx by 1 plus x power 8. Here the powers gets multiplied. X power 4 square will be x power 8. Correct? From this dt by 4 I can write. dt divided by 4. 4 comes down. dt by 4 is equal to x cube cross multiply x cube dx divided by 1 plus x power 4 square is x power 8. Correct? The powers gets multiplied. 4 into 2 is 8. So x cube dx by 1 plus x power 8. this part, x cube dx, x cube dx by 1 plus x power 8. What is rounded off here? X cube dx by 1 plus x power 8. That is dt by 4. dt by 4 means keep 1 by 4 outside. Okay. This is 1 by 4 keep outside. Integral of sine of tan inverse x power 4 is t. Correct? So x cube dx by 1 plus x power 8. X cube dx by 1 plus x power 8 is dt by 4. dt by 4 means keep 1 by 4 outside. Sine of tan inverse x power 4 is t. Integral of sine t is minus cos t. Correct? So this is equal to minus 1 by 4 cos t plus c, which is equal to minus 1 by 4 cos of, what is the t? Substitute back. T is tan inverse x power 4 plus a constant c. Minus 1 by 4 cos of tan inverse x power 4 plus a constant using method of substitution. Move on to the next one. Integral of 1 plus log x the whole square divided by x dx. Terms inside the bracket, will take it as t. Put t equal to 1 plus log x. Derivative of 1 plus log x. Derivative of 1 is 0. Derivative of log x is 1 by x. Correct? Put t equal to 1 plus log x. Put t is equal to 1 plus log x. Method of substitution. Because you know that derivative of 1 is 0. Derivative of log x is 1 by x. Divided by x means into 1 by x. What you are going to substitute and its derivative. Both are present in the given integral. So it's suitable to use the method of substitution. Differentiate this. Dt by dx. Derivative of 1 is 0. Derivative of log x is 1 by x. So from this dt is equal to dx by x. Dx by x. So dx by x is dt. Take the integral as I. Let I is equal to integral of 1 plus log x the whole square divided by x into dx. Correct? This is equal to integral of, what is 1 plus log x? We have taken t. So the given integral becomes t square dx by x. Dx by x is dt. Integral of t square with respect to t is t cube divided by 3 plus c. Finally substitute back for t. T is 1 plus log x. So 1 plus log x the whole cube divided by 3 plus a constant c. Next one, 28th. Integral of 10x power 9 plus 10 to the power x log 10 divided by x power 10 plus 10 power x. By looking at this integral, we can make out that if you differentiate the denominator, we get the numerator. Derivative of x power 10 is 10x power 9, which is found in the numerator. Derivative of 10 to the power x is 10 to the power x into log 10. So I will put t as a denominator. It becomes integral of dt by t, log of mod t. For competitive exams, directly we can answer. This answer is log of mod x power 10 plus 10 power x over plus a constant. Orally we can answer, but still I am doing all the steps in detail. For board exams, if this question is asked, you should do it in proper way, no? So put t is equal to denominator. Put t is equal to x power 10 plus 10 power x. Differentiate this. dt by dx. dt by dx is equal to derivative of x power 10 is 10x power 9. Derivative of 10 to the power x is 10 to the power x into log 10 base e. Correct? From this dt is equal to what we have, 10x power 9 plus 10 to the power x log 10 base e into dx. So numerator is dt. 10x power 9 plus 10 to the power x log 10 dx is dt. Take the integral as I is equal to 10x power 9 plus 10 to the power x log 10 base e divided by x power 10 plus 10 power x. Correct? numerator is dt, correct? 10x power 9 plus 10 to the power x log 10 base z, whole thing is multiplied by dx. This is dt here. Numerator is dt and denominator is t. Integral of dt by t is log of mod t. Log of mod t plus c. This becomes log of mod. What is it? T is substitute back. T is x power 10 plus 10 power x. Move on to the next one. Integral of sin x by sin of x plus alpha. Alpha is a constant here. X is a variable. Alpha is a constant. So you know sin of x plus alpha, the compound angle formula, sin of a plus b, sin a cos b plus cos a sin b, right? Sin of x plus alpha, if I expand using compound angle formula, it becomes sin x cos alpha plus cos x sin alpha. But denominator will contain two terms. It is not so suitable to simplify, correct? If it is denominator containing two terms, we can't separate the terms. If I got something like this, a by b plus c, I can't simplify it further. Whereas if numerator contains two terms, I can separate out the terms. Here it's not possible to separate the terms, right? You can't write this as a by b plus a by c. It's not possible. It's meaningless. It becomes, correct? It's not equal to a by b plus a by c. So it's not possible. Suppose if numerator contains two terms, a plus b by c, then I can separate the terms. See, my ultimate aim is to reduce the integral to the standard form, right? So I can make a substitution for this integral as t equal to x plus alpha, right? Everything in terms of t, so that numerator contains two terms. If it is plus or minus, that doesn't matter. Whether it is a plus b by c or a minus b by c, that is not important for us. So I should make a substitution in this integral so that numerator contains two terms, so that it is possible to separate the terms and then integrate. So integrating any function, remember that it should be reduced to the standard form, then only it's possible to integrate. So I'll make a substitution in this case as t equal to x plus alpha. Write everything in terms of t and simplify it. Okay. So this is for your information. If numerator contains two terms, I can separate the terms. A plus b by c is a by c plus b by c for c not equal to 0. If denominator contains two terms, then I can't separate the terms. Correct? So that's the idea of this problem. Take the integral as I first. Let I be equal to, let I is equal to integral of sin x divided by sin of x plus alpha. Put t is equal to x plus alpha first. To begin with, what we do? Put t equal to x plus alpha. Put t equal to x plus alpha. This implies dt by dx. dt by dx is equal to 1. Derivative of alpha is 0 because alpha being a constant, derivative of constant is 0. So dt equal to dx from this. dt is equal to dx. Correct? Cross multiply. dt equal to dx. So write everything in terms of t at this stage. So this becomes integral of sine of, what is x? If t is x plus alpha, x will be t minus alpha. Correct? X how much? T minus alpha. Divided by sine of, what is x plus alpha? T. What is dx? dx is same as dt. Now expand this, the compound angle formula, sine of t minus alpha, sine t cos alpha minus cos t sin alpha. Expand it. This becomes integral of sin t into cos alpha minus cos t into sin alpha divided by sin t dt is there. Correct? Expanding using sin of a minus b, sin a cos b minus cos a sin b. Now separate the terms. Sin t cos alpha divided by sin t minus cos t sin alpha divided by sin t. Separate the terms. Separating the terms. What we get from this? This is sin t cos alpha divided by sin t minus cos t sin alpha divided by sin t. Correct? So this becomes, the given integral I becomes equal to, correct? Separate the terms. Sin t cancels. Correct? Cos alpha, and cos by sin is cot. So given integral becomes cos alpha minus sin alpha into cos t by sin t is cot t. So what do you get? Integral of cos alpha. Alpha is a constant. So cos alpha is also constant. Don't write integral of cos alpha as sin alpha. It's wrong. Because alpha is a constant. Cos alpha is a constant. Integral of constant is constant into t. Because I'm integrating with respect to t. So integral of cos alpha becomes what? Cos alpha into t minus constant into variable, correct? Sin alpha is a constant. Constant keep as is. Integral of cot t is log of mod sin t, correct? With respect to t, I'm integrating. Sin alpha keep as it is. Integral of cot t is log of mod sin t plus a constant c. Finally, substitute back for t. T is x plus alpha, correct? The t is x plus alpha. So I'm getting cos alpha into t is x plus alpha minus sin alpha into log of mod sin of what is the t? X plus alpha plus a constant c. Hope you understand. Finally, substitute back for t. Integral of constant is constant into t because I am integrating with respect to t. Integral of cos alpha, don't write sin alpha. Okay, be careful, be cautious about this. Integral of cos alpha is cos alpha into t. T substitute back. T is x plus alpha. Constant into variable. Constant keep as it is. Integral of cot t is log of mod sin t. T you substitute back. T is x plus alpha. Okay. Move on to the next one. Integral of x into e power x square. Here I'll use method of substitution. Put t equal to x square because derivative of x square is 2x. X into dx becomes a dt by 2. Take the integral as I. Let I is equal to integral of x into e power x square dx. Put t equal to x square. The method of substitution. Differentiate this. Dt by dx. Derivative of x square is 2x. That means dt by 2 is equal to x into dx. Dt by 2 is equal to x into dx. Dt by 2 means you keep 1 by 2 outside. 1 by 2 outside. Integral of e power x square is t. Correct? X into dx is dt by 2. Dt by 2 means 1 by 2 into dt. 1 by 2. Half is kept outside. E power x square is t. So dt I'll write here. Half dt. Integral of e power t is e power t. Correct? With respect to t. Substitute back for t finally. So answer is half into e power x square plus c. Simple question. Don't use any other method by parts and all. Use method of substitution. Integration by parts. Some students will apply integration by parts. Don't make it complicated. Simple question. Put t equal to x square. Derivative of x square 2x. X into dx is dt by 2. Move on to the next one. Integral of e power 2x minus e power minus 2x divided by e power 2x plus e power minus 2x. If you differentiate the denominator, we get the numerator. Not exactly. Of course, one constant 2 is missing if you differentiate. Correct? So, and also one more thing, remember, dt or dx or du, such terms should be present only in the numerator. It can't be present in the denominator. Okay, so you may ask the question, can I write dt or dx in the denominator? It becomes meaningless. It should be present only in the numerator only. Okay, so I'll put t as denominator. If you differentiate the denominator, I can get the numerator with the constant 2 missing. Okay, so dt by 2 it becomes. If you differentiate the denominator, suppose you take t equal to denominator and differentiate, numerator will be dt by 2. Okay, take the integral as I. Let I is equal to integral of e power 2x minus e power minus 2x divided by e power 2x plus e power minus 2x. What we'll do is make a substitution for this. Put t is equal to denominator. Put t is equal to e power 2x plus e power minus 2x. Differentiate this. dt by dx. dt by dx is equal to derivative of e power 2x. E power 2x into derivative of 2x2. Derivative of e power minus 2x. E power minus 2x into derivative of minus 2x minus 2. So I can take 2 common from this. I can rewrite this as dt by 2. dt by 2 is equal to e power 2x plus into minus is minus e power minus 2x into dx. Correct? 2 is common there. 2 comes down. So numerator e power 2x minus e power minus 2x into dx. So dt by 2. dt by 2 means keep 1 by 2 outside. 1 by 2 outside. Integral of dt divided by denominator is t. Correct? Numerator is dt by 2. Correct? dt by 2 means half dt. Half is kept outside. dt by denominator is t. According to this, denominator is t. Integral of dt by t is log of mod t. Half into log of mod t plus c. Half into log of mod, what is the t? You substitute back. T is e power 2x plus e power minus 2x. Hope you understand this simple question. If you differentiate the numerator, I can get the denominator, but don't keep dt in the denominator, it becomes meaningless. Okay, hope you understand. By differentiating the denominator, I can get the numerator, use that concept and get the answer. On to the next one. This question is almost same as the previous one. I can reduce this integral to the form what we had in the previous question. I can reduce it to this form. See, observe the form of this. E power 2x is present in the numerator and denominator. E power minus 2x is present in the numerator as well as in the denominator. Only difference is numerator, in between these two minus, in between these two in the denominator is plus. Correct? I should reduce that question number 32 to the form of 31st question. See what we have in the 31st question, e power 2x minus e power minus 2x by e power 2x plus e power minus 2x. I want e power 2x and e power minus 2x. That form I should have. So what we'll do is, I'll reduce this question to that form. That means I'll take e power x common from the numerator and denominator. E power x is not common actually. Forcibly I'll take it out and balance it by dividing by e power x. Take the integral as I. I is equal to integral of e power 2x minus 1 divided by e power 2x plus 1. Correct? This becomes integral of, I'll take e power x common from this. What do you get? E power x minus e power minus x. If you take e power x common, so that e power x into e power x becomes e power 2x. If you multiply means adding the powers, because the bases are same, no? Add the powers, x plus x to x. E power x into e power x, e power 2x. E power x into e power minus x is e power 0. E power 0 is 1. Correct? Add the powers. Multiplying means adding the powers. Denominator also. E power x common. So what remains? E power x plus e power minus x. Hope I understand. Taking e power x common from the numerator and denominator. Correct? This 1 becomes e power minus x, because e power x into e power minus x is 1. Because 1 is e power x into e power minus x, which is e power x minus x. X minus x 0. E power 0 is 1, right? 1 is e power 0. So e power x cancels here, numerator and denominator. What is left out? E power x minus e power minus x divided by e power x plus e power minus x. Now this is almost same as the earlier question, right? Put t as a denominator. If you differentiate the denominator, I get the numerator. Integral of dt by t, it becomes log of mod t. Then substitute back for t finally. Hope you understand this. Put t is equal to denominator. Put t equal to denominator. E power x plus e power minus x. From this, differentiate dt by dx. Derivative of e power x is e power x. Derivative of e power minus x is minus e power minus x. Cross multiply. So that we get dt is equal to e power x minus e power minus x into dx. So that numerator is dt, denominator is t. Integral of dt by t. Integral of dt by t is log of mod t plus c. Finally, substitute back for t. T is e power x plus e power minus x. Hope you understand this. Now what is the next one? Integral of x power 4 minus x whole power 1 by 4 divided by x power 5 with respect to x. This kind of problem, what we do is, we take the highest power of x common in the numerator inside the bracket. Highest power of x is x power 4. Actually, nothing is common. Still, I am taking it out and balance it by dividing by x power 4 for the term. Take the integral as I first. Let I is equal to integral of x power 4 minus x whole to the power 1 by 4 divided by x power 5 dx. What we do is, take x power 4 common from the numerator. X power 4 if you take out, what remains? 1 minus x by x power 4, correct? Whole to the power 1 by 4 divided by x power 5 dx. Correct? Taking x power 4 common there. X power 4 power 1 by 4 becomes x. The powers gets multiplied, no? X power 4 to the power 1 by 4 will be x. So this is equal to integral of x into, what we have here is 1 minus x by x power 4 is 1 by x cube whole to the power 1 by 4 divided by x power 5. 1x will cancel here. 1x will cancel, becomes 1 by x power 4, correct? So I is equal to, what we have, integral of 1 minus 1 by x cube, 1 minus 1 by x cube to the power 1 by 4 divided by x power 4, correct? Now what I'll do is, I'll take t as terms inside the bracket terms. 1 minus 1 by x cube as t. If you differentiate that, I can get 1 by x power 4. Put t equal to 1 minus 1 by x cube. These kind of questions are asked in the competitive exams. Even CET also 2 times this type of question was asked. In 2025 also, in 2015 also this type of question. Even in JEE exams also this type of question is very common. Put t is equal to 1 minus 1 by x cube. Differentiate this. dt by dx. Derivative of 1 is 0. Derivative of 1 by x cube is minus 3 by x power 4. Minus of minus will become plus. Minus already there. Derivative of 1 by x power n formula. I am using this. Derivative of 1 by x power n. What is derivative of 1 by x power n? Derivative of 1 by x power n is minus n divided by x power n plus 1. Correct? So derivative of 1 by x cube is minus 3 divided by x power 4. So dx by x power 4 will be dt by 3 from this. dt by 3. dt divided by 3. Minus of minus becomes plus. dt by 3 is equal to dx by x power 4. So dx by x power 4 is dt by 3. dt by 3 means keep 1 by 3 outside. Integral of, what is 1 minus 1 by x cube? T. So it becomes t power 1 by 4 dt. Correct? 1 minus 1 by x cube is taken as t, and dx by x power 4 is dt by 3. Integral of t power 1 by 4. Integral of t power 1 by 4 is t power 1 by 4 plus 1, which is 5 by 4 divided by 5 by 4 plus a constant c. This 4 will go up. So 5 into 3, 15. So I'm getting 4 by 15. Finally substitute back for t. T is 1 minus 1 by x cube. 1 minus 1 by x cube whole to the power 5 by 4 plus a constant c. If you want, you can take LCM inside the bracket and simplify further 1 or 2 steps. Okay. Using integral of x power n formula. Integral of x power n is x power n plus 1 by n plus 1. 1 by 4 plus 1 is 5 by 4. So this 4 goes to numerator. Denominator goes to numerator. 5 into 3 is 15. 4 by 15. 1 minus 1 by x cube to the power 5 by 4 plus c is the answer. On to the next one. Integral of cos 6x into root of 1 plus sin 6x. Normally terms inside the bracket, terms inside the square root, terms which is present in the power are taken as t. In this case, we'll take t equal to 1 plus sin 6x. Derivative of 1 0. Derivative of sin 6x is going to be cos 6x into 6. Correct? So cos 6x into dx becomes dt by 6. Use method of substitution. Put t equal to 1 plus sin 6x. Put t is equal to 1 plus sin 6x. This implies dt by dx. Derivative of 1 is 0. Derivative of sin 6x is cos 6x into derivative of 6x is 6. So dt by 6. dt by 6 is equal to cos 6x into dx. So given integral becomes I is equal to integral of cos 6x into square root of 1 plus sin 6x. Given integral becomes what we get from this cos 6x into dx will be dt by 6. dt by 6 means 1 by 6 into dt. 1 by 6 keep outside. 1 by 6 dt root of 1 plus sin 6x. 1 plus sin 6x is t. Integral of root t is 2 by 3 t power 3 by 2. Integral of root t is 2 by 3 t to the power 3 by 2 plus a constant c. We can cancel 2 1s are 2 3s are correct. So it becomes 1 by 9. 2 1s are 2 3s are 3 into 3 9. 1 by 9. T is substitute back finally. T is 1 plus sin 6x. 1 plus sin 6x whole to the power 3 by 2 plus a constant. On to the next one. Integral of sin cube x into cos per x. Here the power of sin is odd number and the power of cos is even number. There are methods for this actually. With the power of, if it is integral of the type sin power mx into cos power nx, no? If the integral takes this form, sin power mx into cos power nx. In this case, what we do is, if the power of sin is odd number, then put t equal to cos x. Learn this method. If the power of cos is odd number, put t as a sin x. Okay. If the powers of both sin x and cos x are odd number, we can go for either t equal to sin x or t equal to cos x, any method. And if both the powers of sin and cos are even number, then we can use the power reducing formula, sin square x, 1 minus cos 2x by 2, cos square x, 1 plus cos 2x by 2. I repeat once again, all these things I will do it in detail in the synopsis part of indefinite integrals, which is required for various competitive exams, CET, NDA, JEE, everything I'll be covering. Okay, synopsis part of the each and every chapter will be done along with examples. Please make a note of this. Okay, you can subscribe to my YouTube channel Abhiram's Maths Marathon. It's quite useful. I'll be uploading more and more videos in the coming days, and a lot of content will be there. Quality is there. Okay, so lot of new things you're going to learn definitely. So the integral takes this form, sin power mx into cos power nx. I repeat what I told. If the power of sine is odd number, put t equal to cos x. If the power of cos is odd number, put t equal to sin x. If the powers of both sine and cos are odd number, you can go by any method. You can put either t equal to sin x or you can put t equal to cos x. If both the powers of sine and cos are even natural numbers, in that case, you can use the power reducing formula. Sin square x equal to 1 minus cos 2x by 2. Cos square x equal to 1 plus cos 2x by 2. That formula is you have to use and then integrate. Okay, hope you understand. Here the power of sine is odd number, so I'll put t equal to cos x. And also I'll split that sine cube x as sin x into sin square x and write sin square x as 1 minus cos square x. Hope you understand. I is equal to integral of sin cube x into cos square x dx. Correct? Split this sin cube x as sin square x into sin x. I wrote sin square x cos square x into sin x. Sin cube is split into sin square into sin. Sin square x you write 1 minus cos square x. Sin square x you write 1 minus cos square x. Like this. Sin square x is 1 minus cos square x. Now use method of substitution. As I told, the power of sine is odd number, put t equal to cos x. Derivative of cos x minus sin x. Sin x into dx becomes minus dt. Understood? Put t is equal to cos x. Put t is equal to cos x. Differentiate this. dt by dx. dt by dx. Derivative of cos x minus sin x. Or from this minus dt is equal to sin x into dx. Sin x into dx is minus dt. Minus you keep outside. Minus integral of 1 minus t square into t square. Sin x into dx is minus kept outside, so dt I'll write. Okay. Cos x is t. 1 minus t square into t square. Sin x into dx. This part is minus dt, minus kept outside. Now multiply. Open the bracket. 1 into t square minus t power 4. And minus also I can multiply inside. Minus of this becomes t square minus t power 4. Correct? Now multiply this minus sign inside. Minus into minus plus. Integral of what we get is t power 4 minus t square. Integral of t power 4 is t power 5 by 5. Integral of t square is t cube by 3. Correct? Minus I multiply inside. Minus into minus plus t power 4 minus t square. Integral of t power 4 is t power 5 divided by 5. Integral of t square is t cube divided by 3 plus a constant c. Finally substitute back for t. T is cos x. So I am going to get cos power 5x divided by 5 minus cos cube x divided by 3 plus a constant c. Hope I understand this. Simple question. Learn the concept of integrals of the type sin power mx into cos power nx for various cases. Both m and n can be odd numbers. Both m and n can be even numbers. Correct? M can be odd, n can be even, or m can be even, n can be odd. Different cases are there. On to the next one. Integral of x by root of x plus 4. Root of x plus 4 is there. Root is highlighted here. Correct? Terms inside the root, you should take it as t and write everything in terms of t and then integrate. Take I is equal to, let I is equal to integral of x by root of x plus 4. Put t is equal to x plus 4. Use method of substitution. Put t equal to x plus 4. This implies dt by dx is equal to 1. From this, dt is equal to dx. Write everything in terms of t now. What is x from this? Because t is x plus 4, x is t minus 4. Dx is same as dt divided by root of what is x plus 4 t. Correct? Dx is same as dt, x is t minus 4. Separate the terms and write integral of t by root t minus 4 by root t. Separate the terms like this. T by root t is root t, because t is root t in root t, one root t cancels. This becomes what? Integral of root t minus 4 into 1 by root t. You can write like this. Integral of root t is 2 by 3 t power 3 by 2. Correct? 2 by 3 t power 3 by 2 minus 4 into integral of 1 by root t is 2 root t. 2 root t plus a constant c. Finally, substitute back for t. 2 by 3 into what is t? X plus 4. X plus 4 to the power 3 by 2 minus 8 into root of t is x plus 4 plus a constant c. T is x plus 4. Okay. Substitute back finally. Our aim is to reduce the integral to standard form. That's the main aim. Okay. So what is highlighted is the root. So terms inside the root is taken as t. Right? T equal to x plus 4. Differentiate. Derivative of x 1. Derivative of 4 is 0. Cross multiply. Dt equal to dx. Dx is same as dt. So x is t minus 4. Root of x plus 4 is t. Separate the terms. T by root t minus 4 by root t. T by root t is root t. 4 by root t is 4 into 1 by root t. Integral of root t is 2 by 3 t power 3 by 2. Integral of 1 by root t is 2 root t. 8 root t. Substitute back for t. Fine. Move on to the next one. Question number 37. Integral of 2 cos x minus 3 sin x by 6 cos x plus 4 sin x. First you observe that in the denominator 2 is common, right? 6 and 4. Between those two numbers 2 is common. If you take 2 out in the denominator, what remains inside the bracket is 3 cos x plus 2 sin x. And 3 cos x plus 2 sin x, if you differentiate, I get the numerator. Hope I understand. Let I is equal to integral of 2 cos x minus 3 sin x divided by 6 cos x plus 4 sin x. So this becomes integral of denominator, you take 2 common. So what remains? 3 cos x plus 2 sin x. Here it is 2 cos x minus 3 sin x. Now terms inside the bracket, you take it as t and differentiate that bracket, you will get the numerator. Becomes half dt by t. Half we keep outside. Divide by 2 means half we keep outside. Integral of dt by t, log of mod t will get. Put t is equal to terms inside the bracket of denominator. Put t is equal to 3 cos x plus 2 sin x. From this dt by dx. Differentiate. Dt by dx. Derivative of 3 cos x minus 3 sin x. Derivative of 2 sin x is 2 cos x. Correct? From this cross multiply. Dt is equal to, what I can write is 2 cos x minus 3 sin x. 2 cos x minus 3 sin x into dx. Numerator is dt. Divide by 2 means to keep 1 by 2 outside. 1 by 2 keep outside. numerator is dt according to this, divided by 3 cos x plus 2 sin x is t, dt by t. Integral of dt by t is log of mod t, half log of mod t plus a constant c. Finally, substitute back for t, half log of mod, what is a t? T is 3 cos x plus 2 sin x, 3 cos x plus 2 sin x plus a constant c. Move on to the next one. Integral of x cube minus 1 to the power 1 by 3 into x power 5 dx. What is highlighted is to the power 1 by 3. That means cube root. Terms inside the bracket is x cube minus 1. So we'll put t equal to x cube minus 1. And also we shall write x power 5 as x cube into x square. Because derivative of x cube is 3x square. So x square dx will be dt by 3. I'll write everything in terms of t. Okay. Take the integral as I first. Let I is equal to integral of x cube minus 1 to the power 1 by 3 into x power 5 dx. What we shall do is, we'll write x power 5 as x cube into x square. X cube minus 1 to the power 1 by 3. X power 5 is x cube into x square into dx. Put t equal to x cube minus 1. Put t equal to x cube minus 1. Differentiate this. dt by dx. dt by dx. Derivative of x cube is 3x square. Derivative of 1 is 0. So from this, dt divided by 3 is equal to x square into dx. And also x cube minus 1 is taken as a t, no? From there x cube is t plus 1, right? From this I can write x cube is equal to t plus 1. Because I want to express everything in terms of t, right? So that I can integrate with respect to t. Because I've taken x cube minus 1 as a t, this becomes t power 1 by 3. X cube is how much? Because t is x cube minus 1, x cube is t plus 1, correct? So x cube is t plus 1. X square into dx is dt by 3. So 1 by 3 will keep outside. 1 by 3 outside, dt. Now open the bracket at this stage. Our aim is to reduce the integral to the standard form. So multiply this now. T power 1 by 3 into t. That becomes t power 1 by 3 plus 1. 4 by 3. Plus t power 1 by 3 into 1. That is t power 1 by 3. dt is equal to 1 by 3 into integral of t power 4 by 3 is t power 4 by 3 plus 1 by 4 by 3 plus 1. 4 by 3 plus 1 is 7 by 3. So becomes t power 7 by 3 divided by 7 by 3. Plus integral of t power 1 by 3 is t power 1 by 3 plus 1. 4 by 3 divided by 4 by 3. Plus a constant c. This 3 will go up, correct? Otherwise I can cancel this. 1 by 3 and this 3 will cancel. So 1 by 7. Here 3 cancels. Here also 3 cancels. So what is left is 1 by 7. What is the t you substitute back? T is x cube minus 1. So x cube minus 1 to the power 7 by 3 plus 3 got cancelled. So 1 by 4 into t is x cube minus 1 whole to the power 4 by 3 plus a constant c. Hope you understand. This type of question is asked even in JEE exams also. Okay, splitting x power 5 as x cube into x square. Put in t equal to x cube minus 1. Write everything in terms of t. Because we put t equal to x cube minus 1. Okay, x cube is t plus 1. And derivative of x cube is 3x square. X square into dx is a dt by 3. dt by 3, correct? X cube, x square into dx. So dt by 3 means 1 by 3 is kept outside. Then open the bracket, multiply. Then integrate using the standard formula. Hope you understand this. Next one, integral of x square dx by 2 plus 3x cube the whole cube. Here what is highlighted is the denominator, the brackets, correct? So put t equal to 2 plus 3x cube. Differentiate. I can derive x square in the numerator, no? That can be derived from the denominator. So I'll put t as 2 plus 3x cube. Let I is equal to integral of x square divided by 2 plus 3x cube the whole cube. Put t is equal to 2 plus 3x cube. Put t is equal to 2 plus 3x cube. Differentiate dt by dx. Derivative of 2 is 0. Derivative of 3x cube. 3 into 3x square. 9x square. So dt by 9 is equal to x square dx. dt by 9 is equal to x square dx. So x square dx is dt by 9. dt by 9 is 1 by 9. Keep outside. 1 by 9 integral of dt divided by t cube. Correct? X square dx is dt by 9. Means 1 by 9 is kept outside. dt by. Denominator is a t cube because I've taken t as 2 plus 3x cube. dt by t cube means t cube we take it up. Becomes t power minus 3. 1 by 9 integral of t power minus 3. Integral of x power m formula. Integral of x power n is x power n plus 1 by n plus 1. Integral of t power minus 3 is t power minus 3 plus 1 by minus 3 plus 1. T power minus 2 divided by minus 2. So what we get is minus 1 by 9 2s are 18. T you substitute by t is 2 plus 3x cube. 2 plus 3x cube whole to the power minus 2 plus c. 9 2s are 18. So minus 1 by 18. T is 2 plus 3x cube to the power minus 2. Or I can write it as minus 1 by 18 into 2 plus 3x cube the whole square. Write like this. To the power minus 2 is taken to denominator. Becomes to the power 2. Minus 1 by 18 into 2 plus 3x cube the whole square. Hope you understand all these things. Please practice all the problems. You should get a hold in the subject. The NCERT part now should be very strong. You should practice all the problems of the NCERT level questions first. Then you can go for the competitive part. Okay. On to the next one. Question number 40. Integral of 1 by 1 minus tan x. How to start the problem is always the question. By practicing more number of problems, you'll get the idea. So to begin with, I'll write tan as sine by cos here and take LCM, the denominator. Okay. Let I is equal to integral of 1 by 1 minus tan x. Tan will write sine by cos. 1 by 1 minus tan x is sine x divided by cos x. 1 is 1 by 1 here. Correct? This is LCM we take cos x. So what you get is cos x minus sin x here. Taking LCM as cos x minus sin x by cos. This cos x will go up. So what we get is integral of cos x by cos x minus sin x. Cos x by cos x minus sin x. Then what we'll do is we'll multiply and divide by 2. The main aim is to reduce the integral to the standard form, correct? So for that I'll multiply and divide by 2 here. Half into 2 cos x. Multiply by 2 in the numerator and denominator. And you can write this 2 cos x as cos x plus cos x. Okay. Therefore I is equal to half into integral of 2 cos x is cos x plus cos x. Cos x plus cos x divided by 2 cos x I wrote cos x plus cos x. Denominator keep as it is. Cos x minus sin x. Then in the numerator what you do is add and subtract sin x. Cos x is there, no? Subtract sin x first, then add sin x. Because I want to express the numerator in terms of denominator. I subtracted sin x. Here I'll add sin x. Divided by cos x minus sin x. Now you separate the terms. Separate the terms. Divide this by this, this by this. Okay. Separating the terms. Half into integral of what I'm going to get. Cos x minus sin x divided by cos x minus sin x. Separating the terms. Plus integral of cos x plus sin x divided by cos x minus sin x. So this is equal to half into integral of, this will cancel, becomes 1 dx plus integral of, this we can integrate by method of substitution. Here I separate the terms, so divide this by this, this by this. For this part, no, we can integrate by method of substitution, or else I can divide numerator and denominator by cos. I'll get 1 plus tan x by 1 minus tan x, tan of pi by 4 minus x. That method also we can do. But I'll integrate this by method of substitution, okay? If you differentiate the denominator, derivative of cos x is minus sin x. Derivative of minus sin x is minus cos x. So it becomes minus dt by t, minus log of mod t. For this part, I'm using the method of substitution. I'll write here. T is equal to, put t is equal to cos x minus sin x. Cos x minus sin x. From this, dt by dx, dt by dx, derivative of cos x minus sin x, minus derivative of sin x is cos x, minus common, minus to take it to that side. So I'm getting minus dt is equal to sin x plus cos x into dx, sin x plus cos x into dx, okay, minus and common, derivative cos x minus sin x. Derivative of minus sin x is minus cos x, minus and common. So this becomes minus dt divided by t. So this part, that is equal to half into the I is equal to, the I I am writing, the integral I is equal to half into integral of 1 with respect to x is x, minus plus into minus minus. Integral of dt by t is log of mod t plus c. So this is equal to, finally I am getting the answer, half into x minus log of mod, what is the t you substitute by, t is cos x minus sin x. Next two problems are also same type, okay. Next two problems are these. I shall work out still 1 by 1 plus tan x and integral of 1 by 1 plus cot x. These two problems are very similar to the question number 40, okay, similar to this. Tan is there, means write sin by cos. Take LCM, then multiply and divide by 2. If it is 2 cos x, write cos x plus cos x. Add and subtract sin x. Same concept. Okay. If it is cot x, write cos by sin. Take LCM. If it is sin x, multiply and divide by 2. 2 sin x means sin x plus sin x. Add and subtract cos x. Same story. Same method. How we did this problem. Same way the next two problems. I shall complete it anyway for the sake of completing all the problems of the method of substitution. I've taken all the problems of NCERT exercise 7.2, but some problems, 2 or 3 problems, it doesn't belong to that category. So that I'll be doing in 7.3 in the next exercise, okay. Some questions have been asked in 7.2 in the NCERT exercise which does not belong to the integration by method of substitution, which can be done easily by other methods. So I'm using that, okay. So some exception cases are there. And also included the solved examples of NCERT book connected to 7.2 exercise. Solved examples are also more important for many of the board exams or any other exams. They'll ask even the solved examples. Even those questions have included in this. Okay. So take the integral as I here. I is equal to integral of 1 by 1 plus tan x. Tan you write sin by cos. Integral of 1 by 1 plus tan x is sin x divided by cos x. Tan is sine by cos. Take LCM cos x here. That cos x will go up. Correct? Integral of this becomes cos x divided by cos x plus sin x. Next step, what we should do is multiply and divide by 2. Then write cos 2 cos x as cos x plus cos x. Then add and subtract sin x. Then separate the terms. One term will become 1, another term we can integrate by method of substitution. Quite simple. Multiplying and dividing by 2. Half into integral of 2 cos x divided by cos x plus sin x. 2 cos x we can write cos x plus cos x. Cos x plus cos x divided by cos x plus sin x. In the numerator, what we'll do is add and subtract sin x. So I is equal to half into integral of what we have cos x plus sin x, adding sin x, subtracting sin x, group the terms like this, cos x minus sin x, adding and subtracting sin x in the numerator. Denominator keep as it is, cos x plus sin x. Separate the terms. So this becomes half into integral of cos plus sin by cos plus sin. Cos x plus sin x divided by cos x plus sin x. Plus integral of cos x minus sin x divided by cos x plus sin x. This becomes equal to half into integral of 1 with respect to x. For this, we can use method of substitution, or else I can divide numerator and denominator by cos x. Whenever you get expression of this type, cos minus sin by cos plus sin, you are dividing numerator and denominator by cos and getting the answer. Okay. 1 minus tan x by 1 plus tan x, tan of pi by 4 minus x. Same type of expression we got here also. Correct? Here we got cos plus sin by cos minus sin. 1 plus tan x by 1 minus tan x. Tan of pi by 4 plus x we got. But now we are getting tan of pi by 4 minus x. This method also we can do. I am going by method of substitution. Any method is possible here. Okay. Don't have to do use method of substitution only. I'll write the steps here. Put t equal to denominator. Put t is equal to cos x plus sin x. Differentiate this. Dt by dx. Derivative of cos x minus sin x. And derivative of sin x is cos x. So I am getting cos x minus sin x into dx. Correct? So dt is equal to cos x minus sin x into dx. dt is equal to cos x minus sin x into dx. Cos x minus sin x into dx. This part is dt. Integral of dt divided by t. So this is equal to half into integral of 1 with respect to x is x. Integral of dt by t is log of mod t. Log of mod t plus a constant c. So this is equal to half into x plus log of mod t. Log of mod. What is the t? Substitute back. T is cos x plus sin x plus a constant c. Hope you understand. Both same type of questions, correct? Even the previous one we had same type. Because here we got half into x minus log of mod cos x minus sin x. You can generalize these type of integrals. Half into x plus log of mod cos x plus sin x. Next one we got integral of 1 by 1 plus cot x. Same story here also. Cot divide cos by sin. Take LCM. Multiply and divide by 2. 2 sin x will be sin x plus sin x. Add and subtract cos x. Separate the terms. Correct? Integration by method of substitution for one term. Another term integral of 1 will be x. Like that. Take the integral as I. Let I is equal to integral of 1 by 1 plus cot x. 1 by 1 plus cot x. Cot you write cos by sin is equal to integral of 1 by 1 plus cot x, right, cos x divided by sin x. Take common denominator sin x, correct, that sin x will go up. Sin x divided by sin x plus cos x. At this stage what we should do, multiply and divide by 2. 1 by 2 into 2 sin x divided by sin x plus cos x. 2 sin x we can write it as sin x plus sin x. Therefore I is equal to half into integral of 2 sin x is sin x plus sin x. Add and subtract cos x in the numerator. Denominator keep as it is. Sin x plus cos x is equal to half into integral of sin x plus cos x plus sin x minus cos x. Add and subtract cos x divided by sin x plus cos x. At this stage we can separate the terms. Half into integral of this by this by this. Sin x plus cos x divided by sin x plus cos x. Separate the terms. Sin x plus cos x divided by sin x plus cos x with respect to x. Correct? Open a bracket here. Plus integral of sin x minus cos x divided by sin x plus cos x. This can be done by integration or by method of substitution. Here this numerator denominator same cancels out. Integral of 1 it becomes half into integral of 1 with respect to x plus integral of, here if you differentiate the denominator we get the numerator. Derivative of sine cos. Derivative cos is minus and of course minus dt. Correct? Put t equal to denominator. I'll show the steps here. Put t equal to denominator. Put t is equal to sin x plus cos x. T equal to sin x plus cos x. Differentiate this. dt by dx. Derivative of sin x cos x. Derivative of cos x minus sin x. Correct? So here this is minus dt. Correct? You can take minus and common from this. So I'll get minus dt is equal to, if you take a minus and common from this and shift it to that side, minus dt will be sin x minus cos x into dx. Correct? So sin x minus cos x into dx is minus dt. Minus dt divided by t. That's equal to half into integral of 1 with respect to x is x plus into minus minus. Integral of dt by t is log of mod t. Log of mod t plus c. T finally substitute back. Half into x minus log of mod t. What is t? Sin x plus cos x. Hope understand this. Derivative of sin is cos, derivative of cos is minus sin. I take a minus and common from this. Cos minus sin is minus of sin minus cos. That minus is shifted to that side. So sin x minus cos x into dx is minus dt I wrote. Okay, minus dt by t. Plus into minus is minus. Integral of dt by t is log of mod t. Finally substitute back for t. T is sin x plus cos x. So answer is half into x minus log of mod sin x plus cos x. You can generalize these three problems. Okay, almost same the concept. Here we got half into x plus log of mod cos plus sin. Here I am getting half into x minus log of mod sin plus cos. Correct? You can try integral of 1 by 1 minus cot x as well. Okay, so similar type of question. It's not found in the NCERT book, this 1 by 1 minus cot x. Can try. So with this, we completed the integration by method of substitution. Various questions we have discussed from the NCERT exercise. Even the solved examples have taken. Also given the proof of integral of tan x, which is log of mod secant x plus c, integral of cot x, log of mod sin x plus c, integral of secant x, log of mod secant x plus tan x plus c, and integral of cosec x, log of mod cosec x minus cot x plus c. All the problems from the NCERT exercise 7.2 connected to integration by method of substitution has been discussed in this session. I'll be uploading more and more number of videos concentrating on NCERT exercise along with concepts, also for KCET, JEE mains, and also many more competitive exams like NDA and other exams. Okay, with this we'll conclude. Thank you.